Hello grade 11s, let us have a look at this paper as a way of preparing for the mid-year exams. And engage on the comment section if you have any troubles following me on this review, or if you need perhaps some look into of some questions that are probably giving you problems or that you perhaps need assistance with. Otherwise, guys, don't focus on which paper this is and where it comes from. I think what is important is to look at the content and to look at how to approach questions and exactly how to use the knowledge that you already have. Okay, so we're going to take this paper from November 2024, which was written in the EC. Of course, this is the final paper. It has all the topics for paper 1. But the main topics here for mid-year exams is going to be every topic except the last two, which is financial maths and probabilities. But I'm going to do it all so that you can also see how to handle certain questions when it comes to term 3 materials. And usually some of you may find this video essentially at the end of the year. Others are going to see it long beforehand, which is good. But those who see it at the very end might not be so lucky, because you need time to practice these things. You need time to examine and carefully analyze questions in the method that I'm about to show you. Anyway, we read instructions for each paper and we need to read them with understanding of the implications. But we commit instructions of this nature and this nature to memory, because they play a central role in how we get full marks for each question. Anyway, guys, my chair and my table make a lot of noise, so when I move around, that's what happens, because I'm using the microphone of the tablet. I don't have a microphone that can quieten all of that, so you bear with that. I hope it's not going to be too annoying for you to not focus on the issue at hand. Now let's get to question 1. So question 1 is what we term algebra. But in grade 11, usually it's more than one question. It's really, in fact, if I can tell you, honestly speaking, algebra is all questions of term 1. Sort of paper 1. That's pure algebra. But of course, in different formats. The first question is just what we would call pure algebra in a way. But we can see that some techniques from applications of algebra still come back, because when you get to functions, that's just a more advanced or more deeper thought into algebra. Number patterns, it's perhaps applications of algebra. Financial maths, applications of algebra, same. Probabilities, it's more like arithmetic in a way. Sometimes algebra can be brought in, even some sense of functions as well. So you must just know everything is interconnected. Don't separate it too much in your brain. So let's look at 1.1. So we've got 1.1.1. We are solving for x for this quadratic equal to 0. So of course, guys, once you see a quadratic expression, note the discriminant. What does it look like? If it is some square number, then it means we can factorize. Okay? If not, then we use the quadratic formula or completing the square. So whenever you come across a quadratic expression, no matter where, if you're not sure what to do, just check the discriminant. If it is a perfect square, you can attempt to factorize. If not, abandon the thought. You just go for using the quadratic formula or completing the square. All right, so usually when nothing is said, we know factorization will almost always win. So this is the skill to factorize, okay? So we go through this, and then we see that x should be -2 or x should be 4. Nice and easy. So these are questions that every student should know and every student should pass. Okay, now don't be excited you got an answer. Take it back. take it back. So we take the 2 and replace for x. So minus 2 squared is 4. This is minus 2 times 2 is plus 4. 4 plus 4, that's 8. 8 minus 8 is 0. 0 is equal to 0, meaning the left-hand side is equal to the right-hand side. So that holds. 4 in there, we get 16. Here we get minus 8. So 16 minus 8 is 8. 8 minus 8 is 0. Then we have 0 is equal to 0. And so the left-hand side is equal to the right-hand side. Now we can sit comfortably with our solutions. Of course, usually there's a mark for factorization, because when we solve a mathematical problem, we go through some 3 steps. And I can tell you guys, this thing is both directive. It helps you to know what to do when faced with a mathematical problem. At the same time, it highlights areas where you should score marks, meaning maximize on those points, even when you don't know the question. First step here, we use our order of operations, BODMAS, mostly in reverse. We do what we call reverse operations. But there are some questions like basic stuff from grade 8, 9 or so, where we do it perhaps in the forward direction, if I would call it. But sometimes we can use this applied and say brackets. If you think of trigonometry, we could be talking about reduction formulae or cofunctions. And here, when applied, this section, we could be talking about special angles. I would call them SPAs. Otherwise, BODMAS is, as we know, we start with brackets, ordinals or exponents, division and multiplication, addition and subtraction of like terms. But when we're applying this, we can think of reduction formulae or cofunctions when we're doing trigonometry or special angles. Right, the second step here is to factorize. Is it the right way that I wrote it? No. Is to factorize. And then, of course, we factorize normally in 3 ways. For your level, highest common factor, difference of 2 squares, or just a polynomial, using long division or some inspection techniques like the bracket method for a quadratic trinomial, and you name them, but they're all built from long division otherwise. And then we've got the third step where we can use an identity. It could be some law, could be even logic, or even a formula. Anything that seems to be some kind of a law, a rule, whatever you call it, etc. So if you can go through these things, I promise you, you will almost always have an idea of how to handle a higher order question. And remember, for higher grade questions, simultaneous equations are almost always involved. Of course, in different formats. Usually these are the multi-step questions. Just remember that. So if you have this in mind, I promise you, you will cruise in mathematics. All right, so let's get to 1.2. So we've got 2x squared minus 3x is equal to 7. All right, so we're told to solve correct to 2 decimal places. That's already an indication the roots here are irrational. Of course, if you don't know, check the discriminant. But now we will start first by writing it in standard order. 2 squared minus 3x minus 7 is equal to 0. Right? So we know that the roots are irrational the moment we see that, but sometimes the examiners may be a bit tricky and not state this, but you have to decide for yourself. So we know that x is going to be minus b plus or minus the square root of b squared minus 4ac, all divided by 2a. Now this implies x is equal to, now what is b? b is the coefficient of x, and where we see b, that's what we put. So we're going to have minus into minus 3 plus or minus the square root of minus 3 squared minus 4 into 2 into minus 7. So I'm already moving quicker. So what is the story? A is the coefficient of the highest power, which is x squared. So this is what we put for A. And as you can see, we put the 2 there for A. All right. So we're going to have 2 into 2. As you can see, we still have A there. And then for C, this is the constant term. And for C, we put that, and that's what we see over there. So ensure that this step is done properly. It's critical. These are free marks. Therefore, X is... Now, some teachers advocate that you simplify a bit on the square root or what is under the square root. But I find that it's a waste of time, truly, because it is insignificant. What matters is the answers. As long as we have correct substitutions, the rest of the story is just as clear as the back of a goat. A white goat on a parched field, right? Right, or scorched. Maybe let's say scorched, not parched. When it's parched, it means it's winter season, isn't it? Yes. So I'm getting the first answer is 2,7. Now to 2 decimal places, it's going to be 7. 7 or x is going to be equal to, so we just go and change the answer there. Unfortunately, using the quadratic formula is a little bit labor intensive and tedious, but you have to be meticulous because it's one way to solve some problems that could easily be a nightmare if we didn't have it. So the second one is going to be minus 1,27 to 2 decimal places. Let me accept that as our answer. Again, folks, don't just be excited you got an answer. Go back to the original so that you don't miss out on just easy marks. Now what we want to do is to substitute each one of these x values onto the left-hand side of that equation. Since this is a whole number, we will then round off to the nearest whole number, whatever we get. If the left-hand side is effectively equal to the right-hand side, then we know our solutions are on point. So 2 into 2,77 squared minus 3 to 2,77. What I'm getting here effectively is 7. So this means the solution holds, okay? Of course, check the second one. Coincidences, guys, have occurred before. Find that there has been a mistake committed in the process of substitutions or writing the answers. A lot of things can occur that will botch everything here. So make sure you've done it well. Again, this one holds. The left-hand side is effectively equal to the right-hand side in the original. Remember, manipulations can be wrong. Find that the 7 was brought in as positive, and these answers will tie up to this manipulated version. But actually, that was not the question. The question was the original question. So you test or check the solutions in the original. And of course, we always get a mark for correct substitutions. Mind you, these substitutions have to be correct. And an extra mark for writing this in standard format. Let me just demonstrate for you what happened here. 3-step approach. We looked at this expression from inspection. We're like, okay, this is quadratic. And essentially, we attempted to factorize. But when we factorized, remember, this is step 2. So we went to step 2. We factorized using inspection, polynomial bracket method, so to speak. Although this is still borrowed from long division, but we call it inspection, whatever you want to say. Then after that, what do we do? BODMAS. We break the brackets and solve each bracket. So this is gone to step 1, brackets off. And that's how we get our solutions. Second, what did we do? We went to step 3. the law or a rule that we need to write a quadratic in standard format before we can solve it. Secondly, we used step 3 again, a formula. Then we did substitutions. Now substitutions, you can decide, but since we're still using the law, you can consider them as part of step 3, or you can call them part of step 1, because this is when we're just putting everything into the structure. And what do we do again? We use BODMAS, which is step 1, to get to the solutions, because there's brackets, you handle them, square roots, you name them, all of these things you just do and finish. At the end of the day, we get our answer, right? So the 3-step approach is not a myth, guys. It's a reality, and you will appreciate it when it comes to higher order questions where you would probably not know what to do. This thing gives you perspective. Okay, let's have a look at this one. This is x plus 1 into 4 minus x, which is greater than 0, where x is an element of natural numbers. Now, we don't normally see this, situation. We normally would deal with x as an element of all real numbers. But this time, natural numbers. Now, this creates a higher grade question rather than the standard. But in any case, quadratic inequalities were a higher grade content, not standard grade content. But now this one you would call a higher grade with an asterisk, because it demands a bit more, commitment from you and a careful approach, so to speak. So here, this is a parabola, and if we multiply x and x here, we get minus x squared. So once the coefficient of x squared is negative, it means our graph is a grumpy face parabola. So we can use the graphical method here to solve the problem. It's not a must, there's many techniques, but to avoid wasting time, I'll just let all these techniques come along as we solve, okay? So this parabola, we know that if we solve, it's going to be minus 1 and 4. And it's going to be stuff like so. Okay, but why does it always want to look terrible? I want it to look nice, man. Yeah, it's much better, man. Don't like ugly things. Anyway, don't listen too much into what I just said. Of course, the y-intercept is going to be 4 because it's just the constants multiplying. So we saw that we're going to get minus 1 and 4 here. But now, notice something. Natural numbers start from 1. So if we say this is 1 over here, so that is 1. Now this simply tells us that the graph does not exist on this part, because this is the part that does not exist with natural numbers. So this means we cannot comment about anything before 1. The graph starts at 1, starts here, whatever the value is, okay? So this is what we know. So this means we want the graph to be greater than 0, meaning above the x-axis. So the graph is above the x-axis here. Okay, so that's where the graph is above the x-axis. So what do we write? We write x must be less than 4. Remember, 0 is not included, so we cannot include 4. But it has to be greater than and equal to 1. Why? Because at 1 it is positive, as well as it is acceptable for the domain of natural numbers. We will not write the minus 1. And then, of course, once we write inequalities, we need to state the domain in which x is found. Sorry, it's not real numbers, but natural numbers. Okay? So, because with inequalities, once we write like that, we also mean any decimals in between. So we need to state now the domain that this is the case, or else we get caught out. So how do we score marks here? Well, we score a mark here for this equal to and greater than, and the other value right there, and of course the domain. It has to come out, because if you don't write the domain, then this doesn't make sense. You are meaning real numbers, so you will lose out. So be very careful of certain notations. Even interval notations don't apply for a set of natural numbers. Never do it. If you do write it, then indicate the domain. If not, you lose those marks, okay? So the graphical method, guys, once this is already factorized, it's very easy. There's no need to waste time on that. All right. Usually, sometimes the sketch may be considered for the extra mark, depending on how the formal marking guidelines are structured. But remember, that is at the discretion of the examiners. What I'm showing you here, how the marks are distributed, is areas where you are supposed to get marks. As you can see, three-step approach, when BODMAS or order of operations are applied, usually in an applied fashion, like reduction formulae, cofunctions, special angles, or in reverse operations rather than the forward way of thinking about it, you always get a mark. Whenever you factorize, always get a mark. Whenever you use an identity, a law, whatever, you get a mark. The reality is, though, the examiners can decide, depending on the gravity of the law or the technique, what role does it play in solving the problem. Then they may not weight it as significant to score a mark. But your job is to make sure you are ready to take marks no matter what. So that's why it is advisable to show all steps in every solution. So now we're given 14 is equal, 14 over p equals p plus 5, and we're told to solve for p. So 1.2.1, well, we will know that 14 over p is equal to p plus 5 all over 1, right? Then we cross multiply there. Technically, cross multiplying is just using the lowest common multiple, which we call it LCM. And this is achieved by multiplying the denominators together and then multiply throughout by the LCM. But it's a very easy and concise way of dealing with the issue without going through the process of wasting time there. All right, so what do we have? P times P is going to be P squared. P times 5 is going to be 5P equals 14, because 1 times 14 is 14. We notice this is a quadratic. We write it in standard form. P squared plus 5P minus 14 is equal to 0. Again, quadratic expression, think of the discriminant. And whatever the discriminant is equal to, if it is a perfect square, then we know we can factorize. But again, this should be second nature already in someone who is doing grade 11, because factorizations are taught heavily in grade 10. I see guys nowadays, you're also doing the bracket method for even grade 8 and grade 9. But we had a lot of heaviness on factorizations of polynomials with groupings, the bracket method, long division in grade 10. In grade 8, we did long division still, but not to that extent. We only factorized mainly taking out the highest common factor there. Anyway, that is P. P14 is going to be plus 7 and minus 2. Those are perfect factorizations for this issue. Therefore, P is a 2, or P is minus 7. Okay? Now, don't be excited. Again, you got answers. Please check these for correctness. Take this value of P and go into the original, provided it is copied correctly. Take this P, we put it there. 14 divided by 2 is 7. Then we take a 2 there. 2 plus 5, that's 7. So 7 is equal to 7. The left-hand side is equal to the right-hand side. There can never be any wrong solution like that. That balances the equation nicely. Put a 7 there. 14 divided by minus 7, we get minus 2. Then minus 7 plus 5 is minus 2. So minus 2 is equal to minus 2. So that's a good solution for this problem. Now the third mark, remember, three-step approach, whenever we factorize, we get a mark. So I believe it is there. But this can also be considered writing this in standard format. This can also be considered cross multiplication, which is effectively multiplying by the lowest common multiple. All right. So that's easy, 3 marks, nothing complicated there. But again, if you want to trace the three-step approach, you would call cross multiplication or multiplying by an LCM as essentially step 3, because that's a law of how to deal with functions. But one may still consider it as step 1, because handling fractions or rational expressions technically is more of what we call like terms. We treat it as such or whatever. Then writing our quadratic in standard format, it's step 3 effectively, because that's a law. Then we factorized using step 2. Then when we deal with brackets, that's step 1, BODMAS, dealing with brackets and solving each factor. So I will not trace it though for each and every question. Please attempt to do this so that whenever you get to higher order questions, you will almost always carve a path on how to attempt it, whether you finish it or not. If you follow this approach, I promise you guys, where marks are, if you're still good before you made any mistakes, you will get those marks. It's nicer when the approach is informed than just a random guess or just simply giving up. You might give up a mark that could be just the difference between scoring a distinction and a mark that is not going to help you, or failing and passing, or just getting a decent mark that places you at an advantage of some sort. So do not take anything for granted. So 1.2.2. Now we need to, hence or otherwise, once this is given, it means we are going to most likely use solutions we had above. Otherwise, solve for this situation. Okay, let's write it out. 14 divided by the square root of x plus 5 is equal to the square root of x plus 5 plus 5. Okay, so as we can see from inspection, we can see this is similar, but p is replacing the square root. So here we can say let p be equal to the square root of x plus 5, right? So this implies that we will have 14 divided by p equals p plus 5. So here this implies that p is equal to 2, or p is equal to minus 7. We don't even waste our time going through the steps now. We'll then say c 1 point, not 1 but 2, c 2.1.1. all right, is it 1.2? oh my lord, what am I doing now? Stupid things now starting to irritate me. 1.2.1. So this implies that the square root of x plus 5 is equal to 2, or the square root of x plus 5 is equal to minus 7. And we know here the gymnastics, but remember, try to do the gymnastics in the next step, not on the first expression, because that was an interpretation of what is above. So don't clutter things, because this is how you lose the track of what you did as a student, and you end up presenting a half-cooked approach. And now we know with radicals, if we want to solve for x, which is inside the radical, we need to do reverse operations. So this is going to imply that x plus 5 is equal to 4, or x plus 5 is 49. Okay, therefore x is going to be, with transpose here we get minus 1, or x with transpose we get 44. Now those are our solutions. Now remember, I always said we cannot settle with the fact that we got the answers. We go back to the original with these solutions and substitute them. Check them for correctness. So minus 1 in there, we get minus 1 plus 5, that's a 4. Square root of 4 is a 2. 14 divided by 2 is 7. Good. Come here. Minus 1 plus 5, that's a 4. Square root of 4 is 2. 2 plus 5 is 7. So 7 is equal to 7. The left hand side is equal to the right hand side. We check the second one. 44 there would give us 49. Square root of 49 is 7. 14 divided by 7, that's 2. Get here, we get 49. Square root there is 7. 7 plus 5 is 12. So 2 is not equal to 12. So this solution needs to be rejected. And we get a mark for rejecting this solution, because technically the gymnastic usually introduces solutions that are not a part of the solution. But the fact that one checks out, it means we are not wrong entirely. So we can accept our approach here. So essentially 2 marks. Of course, we're getting 4 marks here. The most important is to know that we needed to do those substitutions there. And of course, part of the 3-step approach, reverse operations. Usually this warrants a mark. Okay? That's usually how we score those 4 marks. And you can trace the 3-step approach in all of what we did. You will then understand that this thing is really useful. All right, so let's get to simultaneous equations, which is common and very important, because here it's easy, but when it comes elsewhere, it is not so easy. You need to know how to really handle the issues here. So we've got minus 3y is equal to 1 minus x. Now here, we don't want to isolate y because it creates fractions, so avoid fractions. So let's just throw x to the other side and throw y to the other side. So we can say here, therefore, x is going to be 1 plus 3y. We make this equation 1, and then we write the second equation, which is x squared minus 2xy minus y squared, which is an equation of an ellipsoid. Right, so it's more like a circle, but not exactly. So this is equation 2. Now we know here we just use the substitution method. Put 1 into 2. Anyway, so where we see x, we put 1 plus 3y. So this is 1 plus 3y all squared minus 2 into 1 plus 3y times y minus y squared minus 7 is equal to 0. This implies, maybe we might want to shift a bit our implication. Then we fold this out, it's going to be 1 plus 1 times 3, that's 3 times 2, that's 6y plus 9y squared. Minus, we multiply 2 there, we get a 2, we add y, is going to be minus 2y. Then we multiply the 2 there, we get minus 6. Y times y is going to be y squared. Minus y squared minus 7 is equal to 0. So please guys, expanssions and contractions of algebraic expressions you've learned in grade 9, grade 10. There's no excuse here. You need to know how to handle things. Like terms here, let's start with the highest power here, which is y squared. So there the y squared 9 minus 6, that's 3, minus 1, that's 2. So we have 2y squared. And then we're going to follow with the next power, like that. So essentially what do we have? 6 minus y is going to be 6 minus 2, that's a 4. Right? That's a 4. So we've got 4y. Plus 4y. And then we have essentially 1 minus 7, which is minus 6, equal to 0. So you're too far away, bozas. Come close, come close. Hatamelang, hatamelang. Leskantsab. Hagejibaton. Wawon. Now we can divide by 2 there. So we get y squared plus 2y minus 3 is equal to 0. We know we can factorize here. So y and y plus 3 minus 1. Therefore, y is equal to 1, or y is equal to minus 3. Right. And this also concludes that x is going to be, we take this into equation 1, it's going to be 1 plus 3 into 1, or x is going to be 1 minus into minus 3. Was it minus? It was a plus. Nice. So, which is 4. And here, this is going to be minus 2. All right. Okay. All right. Nice and easy. No. This is wrong substitutions. So be very careful, guys. So this is 3 into minus 3. So this becomes minus 9 plus 1, which is minus 8. Okay. Now we have our solutions. Again, guys, this is a lot of concentration is necessary. Mistakes can creep in. A missing of a sign or changing of a sign in a digit can be a nightmare. Now we need to check these solutions, both of them as a pair, because when y is 1, x is 4. We check them where? Into the original, provided it's written well. The linear one is much easier to do this in. So we go in there, we say minus 3 times 4, times 1. That becomes plus 3, minus 3. What am I saying? Minus 3. Now 1 minus 4 is going to be minus 3. So minus 3 is equal to minus 3. Left hand side equals the right hand side. So that pair passes the test. We check the next pair because coincidences have occurred in the past. I promise you. Then we say minus 3 for y. So minus 3 times minus 3. That's a 9. Okay. We take this minus 8 there. 1 minus minus 8. Is 1 plus 8, which is a 9. So these two also pass the test. Good. Now we get the mark for substituting one into the other. Great. Now we derived, or should we say we kind of simplified that expression. That should give us an extra mark, because we see everything is tying nicely. So for 6 marks, we are good. So this is very good, guys. It's a very nice standard grade thing. But I can promise you, it becomes hectic when a student has to apply this and know when to do so. Okay, 1.4. Now we're given if 2x to the exponent minus 1 plus x to the exponent minus 2 is equal to 3 and x is less than 0. Now the question is, for those who know, can the base be negative? Yikes. It depends on the issue at hand. If we're talking functions, this is not acceptable. But we are looking at algebraic equations here. Does it really matter? I'm not too sure. But I'm a bit skeptical about this. But anyway, sometimes the examiners, remember, have solved this problem beforehand. The reason it is being asked in the exam is because they already have a solution and they know exactly what is the significance of this. So sometimes just place a question mark if you're not so sure immediately what this stands for. And we are told to determine without using a calculator. So meaning no decimals, no skipping simplification steps. The value of this situation. Now the question is, guys, is the expression given here a simplified version of this, Or is this a simplified version of that expression? Now, when it comes to questions like this, you're not sure how to go about business. Now, what I often do, I will take the original and say 2x to the minus 1 plus x to the minus 2 equal to 3. I simplify. So it's going to be 2. Remember, in maths, we don't really like negative exponents. So x to the 1 is just x. Plus here is going to be 1 divided by x squared equals 3 over 1. Okay, now we multiply by the common denominator here, which is x squared. So x squared can divide itself, can divide x, can divide 1. So we don't need an LCM, but we just take a common denominator. This is a CD. Please don't say lowest common denominator. If you attend my classes and you say such things, we're not going to be friends, because I don't like people who say things that don't make sense. Unless there's nothing better, of course. Right, so it's just a common denominator, because if we say lowest, the lowest is one of these things. So are you going to choose 1? It's ridiculous. All right, so we then multiply by this common denominator throughout. So here, x will cancel x, so we end up with just 2 times x, which is 2x. Plus now x squared will cancel out or divide to 1. 1 is a multiplicative identity, so it's effectively there, but we don't really see it. Okay, so it's going to be 1 equal to 3 times x squared is going to be 3x squared. Okay, of course, 3 divided by 1 is just itself, so we leave it as such. So now our expression is almost like in a linear format. Remember, I'm saying linear format. I'm not saying it's linear, but it's in a linear format. So remember these things, they're very important to separate. Now this is 3x squared. We bring in this, it's going to be minus 2x. We bring in that minus 1 equal to 0. Can we factorize this? Because we see this is a factorization of some sort. Yes, we may, but it's a quadratic. So this is going to be 3x. Now we need minus 1 here, plus 1 there. Can you see? It's nothing looking like that. Sometimes when you're not sure, take that very second expression and try to simplify it as well. Remember, this is inspection, or should you say RW. This is rough work. You're not answering the question, just trying to figure out how am I going to solve this problem. Now remember, in maths we don't like negative exponents, so this is going to be 2 divided by this expression to the exponent 1, which is just as good as 6x minus 1. Now we can see this is this is a hyperbola. Again, recognize these expressions. This is a hyperbola. This is a hyperbola, and we saw that this one was a parabola. So definitely these two are not the same. So basically the examiner is trying to say to us, solve simultaneously. Can you see simultaneous equations are really haunting you if you don't understand them? But now we can see that if we're solving simultaneously, this is an expression. In fact, it's a hyperbola, but we can perhaps say hyperbolic expression. Hyperbolic expression. This is an equation, it's a parabola, so we can accept that. It's more like a function. Again, you can say quadratic if you don't want to use the word parabolic. You can just say quadratic equation. So we are literally solving simultaneously. Now, we know that this is an expression, so we normally simplify here. The method of solving is to simplify, and we cannot simplify further than this. So this means this gives us solutions. As we can see, it solves. Then it means we take the solutions and then plug them into the next. So this is more like, substitution kind of stuff, which is what we did in 1.3. So can you see how enthusiastic the examiners are? They provide you guys what you already did. Anyway, now we know the approach. We're going to take the first expression, which is 2x to the minus 1 plus x to the minus 2 equals 3. This implies that we've got 2 over x plus 1 over x squared equals 3 over 1. Okay. Now we multiply by x squared, which is our common denominator, so we get 2x plus 1 is equal to 3x squared. We then rearrange our parabola nicely. 3x squared minus 2x minus 1 is equal to 0. So we've already worked it out. It's more like transcribing. Sometimes when you see this works, you can just easily take the solutions from here and plug here. Then when you come to here, just write 1.4. You just say CRW, indicate it where you wrote it. Then you can be marked there, because sometimes you don't want to waste time. Once this works out, the first attempt, just write here CRW. Then the marker is going to go there and mark you. And show though that that part is on the script you submitted and you indicated this question there. Alright, so this is 3x, x minus 1 plus 1. Therefore, we see x here is going to be minus a third, or x is 1. Can you see this is a negative number? And what were we told? X is negative. So it means we're going to choose that solution. So we'll say, therefore, x is minus a third. We reject that one because it is not indicated. So we will say then, now, instead of just substituting, we'll just write this expression 2 into 6x minus 1 to the minus 1 is going to be equal to 2. Simplified first is equal to 2 divided by 6x minus 1, right? Which is going to be equal to 2 divided by 6 into minus a third, minus 1. Now, here, we need to simplify nicely, showing each step, not rushing anything. Minus 6 divided by 3 is going to be minus 2 minus 1. So our answer here, I don't like to stack my answers, but I'm not able to do otherwise. So this is going to be minus 2 over 3. That's it. That's it. So, do you see, guys? This is nothing but simultaneous equations. And the three-step approach always assists in this case. As you can see, we followed it in simplifying this expression up until we saw that, this is different from this one. And then we knew that we are solving simultaneously. A solution from here is then plugged there. And that's the significance of that x minus 0. So the examiner knows that you're not going to know this straight up. So they're giving you clues and hints. But they're not giving you the entire picture. So you have to be on the alert. You need to be aware. And kick it as it comes. Okay, guys? That's good. So essentially, uncovering this solution, I think, is where the mark is. Substituting here, that's where the mark is. And the final value right there. Okay? So that's 3 marks. Now we're scoring 4 marks only. My lord. Usually factorizations is part of the 3-step approach, and usually it's what gives us marks, because without doing it here, we would probably be lost. The rest of the gymnastics, yes, there's lots of areas. We've used laws, like here, of exponents when we've got negative ones, how to change to positive. We've done multiplication by the common denominator. The other issue is that those 2 areas can score a mark, but if the examiners have decided no, it's a no. Again, for this particular paper, you may want to look at the marking guidelines and see how the marks were distributed here. But I promise you, the areas I'm highlighting are usually the areas that you will almost always find being the marking points on the marking guidelines. So if you use this, knowing that this is how I score marks, even when you get stuck in a question and you probably lose time, you cannot go back to it and perhaps check where the wrong or the mistake may have come from. But the fact that you are meticulous in your process initially, until you lost your judgment or your concentration lapsed, you would essentially, guys, score marks, because the marking guidelines are always going to stipulate where marks are supposed to be given, especially if the approach is similar. If the approach is different, of course, whoever is marking is supposed to say, okay, my student or this paper used a different approach but didn't get the same answer. So how do we proceed? They are not at liberty to just mark you down. All right, they have to consult. So this is essentially how we score our first 26 marks in this question. Okay, as you can see, the last question was a higher grade question, and the 1.1.3, that was a higher grade question. Even this one though, it's typical of what we would call a higher grade question, because there you needed to see the technique. Some people choose the K method. Instead of saying P here, they can use K. But the reality is I'm choosing P because it's already given, so that I can essentially show my marker that this expression is similar to that. And the way we solve it is going to be the same. And literally the solutions are the same, except that for this one, they're going to be extended. All right, great. Now let's get to question 2. Question 2, we're supposed to simplify without using the calculator. Okay, great. So we've got 2.1 and we need to simplify that expression. So we've got square root of 32 minus the square root of 18 plus 3 root 3, all divided by square root of 108 plus square root of 8. All right, guys, so usually you first inspect and you will see that, okay, this is the smallest root we can see so far. So we'll try to drive everything to as small a root as possible. But now what is the law here? The law is that we change what is under the radical into its prime factors. But preferably we choose a perfect square first and leave a prime factor, because usually you find that certain numbers are composite numbers, so we need to try and play with the things. Now let's have a look here. 32 is basically 16 times 2. We show this before we show up with the simplified version, or else we will be giving the indication that we used a calculator. So here we need to prove that we did not touch the calculator. 18 is 9 times 2 plus 3 root 3. So we're not going to change this. It is as it is. Divided by 108. Now 108 is going to be a bit nasty. I don't remember and I'm not too sure. So what you do, just say 108, go to the calculator, equal to, it's going to give us 108. You hit the shift button and then you hit the fact button, because there's no need to crack your skull, guys. Time is a factor in the exam, but when you're practicing, try to engage your brain as much as you can. Even during the exam, you can engage it when you can, but don't punish it, because you need the concentration here rather than abusing your brain. So now this one is doing things that I don't like. Okay, I did something wrong. I took the square root. I'm not supposed to do so. 108 equal to, then we say shift and then fact. I'm getting 2 squared times 3 cubed. Nice. We then simplify here. This is going to be 4 times 27. So can you see it's a perfect square, and whatever this is, we don't care. So this is going to be 4 times 27. Sometimes you may not think of it early, so don't punish your brain, guys. You've got calculators, but know how to use them so that you don't lose marks. 8 is 4 times 2. So now we've set up everything. So we come back here and say nice and easy. We're getting here now. What is the story? Square root of 16 is 4 root 2. Minus square root of 9 is 3 root 2. Plus 3 root 3. All divided by square root of 4 is 2 root 27 plus 2 root 2. Great. now we go on. We'll be like 27 is still big. We can reduce this. So this is 4 root 2. In fact, let's not delay anything now. What we see here, we've got like terms. 4 root 2 and 3 root 2 are like terms. So 4 minus 3 is just 1. So this is square root 2 plus 3 root 3. All divided by. Now we're going to have 2. Again, we need to show how we got things done here. This is 9 times 3 plus 2 root 2. We continue, root 2 plus 3 root 3 divided by. Now this is going to be, in fact, we want root 2 to lead, so it's going to be 2 root 2 plus. Remember, when there's nothing here, we can switch the positions. Nothing is wrong. So this is 2 times square root of 9 is going to be 3 root 3. Now when we look on the denominator, we can factorize by taking out the highest common factor. So we've got root 2 plus 3 root 3 divided by, we take 2 out, we end up with root 2 plus 3 root 3. Okay, now the good thing is that this bracket divides the numerator, or the numerator divides that bracket to 1. 1 is a multiplicative what? So our answer is a half. Now to check for correctness, punch this into the calculator, because there's no point in leaving this question unanswered. Then you check by punching into calculator and see what you get. If you're getting a half, you know that all the gymnastics you went about are good, because mistakes can occur in simplification. This is why it's always good to check, so that you don't lose these multiple marks. You see, 4 marks is a lot. So guys, here trying to do these reductions was perfect. I would say these whole ones, good. And then sorting this one up eventually. No. Sorting this one up, that's a mark. Whenever we factorize, we get a mark, and we get our last mark there. So please guys, know how to play the game, and play to win, not to lose or to regret. I should have checked. How did I make this mistake? It's because you don't check religiously. But if you check answers religiously, you will never have this, what happened here? When it happens, you will see it as it happens, because the answers are not going to make sense. They're not going to tie up. Then you check. But if you don't have that habit of checking, I promise you will always think you've done it well. I do make mistakes, thinking I've done it all well, because I sometimes take the checking part for granted. Okay, be very careful, guys. Don't occupy your brains with other things. Just do mathematics. You may not need to do it for life. You just do it for this time being, and it may take you to where you need to be. So we've got 2x to the minus 5 over 2 is equal to 64. Okay, we're solving for x. Now we're doing exponential equations. Okay, this implies, now remember guys, there's many ways of killing a cat, but in this instance, trying to change this to positive exponents is not necessarily going to help, and I'm going to go through a lot of steps. What is important is just to to divide by 2, because it's a multiple. So we end up with x to the minus 5 over 2 is equal to 32. Okay, and mind you, we're not using a calculator, so do not do things that are going to compromise you. So this is x to the minus 5 over 2 is equal to, now 32 is just 32. In this case, we want to show the gymnastic. Now we multiply by the reciprocal of this thing, minus 2 over 5, to get rid of the exponent. And whatever we do to the one hand side, we must also do to the other hand side. So this implies now x is free, because 5 will divide 5, 2 divides 2, 1 minus 1 times minus 1 is plus 1. We don't need to write it up, so we leave it, and then we say, okay, good. But now 32 can be written as 2 to the exponent 5 into the exponent of minus 2 over 5. Again, laws of exponents will say we will multiply the exponents. The 5's divide to 1. Then we've got 2 to the minus 2. So this implies that we've got x divided by 1 over 2 squared, right? We're using exponential rules. Please, guys, we need to show this. So we're changing a negative exponent to a positive exponent. So this is going to be what? A quarter. Now, certain simplifications, as simple as they look, but they can be quite a tedious process, as you can see. Please follow the process, because marks can be sitting where you did not go. And if you made a mistake, then you get 0. But if you try to follow the process, you may score some good marks along the way. All right, so what do we do here? How many marks is this? 3 marks. Of course, the answer is key. I think converting 32 to the power of base 2, in fact, the 5th power of base 2, or we can say 5th degree power of base 2, or 2 to the exponent 5, but never say 2 to the power 5. No. No, 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 no. There's no such a thing. It's 2 to the 5th. Right? You are raising 2 to its 5th power, not 2 to the power 5. Get that right, please. It's going to catch you if you don't get it right. The matriculants of 2025, of course, those who are upgrading from last year, got caught hands down with this issue. And sometimes you guys hear these things and take them for granted. They will haunt you, believe me when I tell you. May not be today, but certainly tomorrow or any other day that is still to come. It will happen when you don't need it to happen. And you will live to regret when you shouldn't. But again, in life, sometimes we learn the hard way. Don't beat yourself too much if that happens, because we all do the same mistake, and usually over and over again. Anyway, how do we mark the rest of this thing? Where's the third mark? Is the gymnastic, isn't it? Yeah, I suppose so. Great, so we're going to 2.2.2. So we've got 3 times 5 to the exponent x minus 5 to the exponent x minus 1 equals 14. So this is suggesting that we've got 3 times 5 to the exponent x minus, we break this using exponential laws, it's going to be 5 to the exponent x times 5 to the minus 1 equals 14. Now, we can factorize here. 5 to the exponent x is the highest common factor, so we've got 3 minus 5 to the exponent minus 1 is basically 1 over 5, so it's 1/5. We can convert that straight up. Now, what do? We simplify the bracket here. Is 5 to the exponent x into 5 times 3, 15 minus 1, that's 14 over 5. Okay, is equal to 14. Then we divide throughout by 14. 5 to the exponent x is going to be 14 over 1. Then we literally multiply with that flipped 5 over 14. And this happens. And what do we have? We've got 5 to the exponent x is equal to 5. Now we show the exponent so that we can show that the same basis, and it means the exponents must also be the same. All right, so very nice and easy. Again, I tell you guys, I tell you all the time, please check the answer for correctness. In fact, I forgot to do so here. When we have an equation, we don't have an excuse not to check. If we put a quarter where x is for the first one, so this is 2 into a quarter to the exponent minus 5 over 2. What is the answer there? It's 64, so it holds nicely. Now let's check 1 in here. So when we put 1 in there, this becomes 5. So 5 times 3 is 15. We put 1 there, it's going to be 0. Any base to the exponent 0 is 1. So 15 minus 1 is 14. So this one holds nicely. Alright, so please don't lose out, guys. Whenever we factorize, we get a mark. So there's just too many issues right now that I see. 5 marks, I don't know why. It's not right. It's not right. Most of the gymnastics here don't matter. Perhaps this one is perhaps very important to write like this. Instead of writing 5, but to show the exponent, I think it's good. Perhaps it's a weak part, I'm not too sure, but we can say, okay, remember BODMAS rules, step 3, when we break this into its respective factors using laws of exponents, is good. So 1, 2, 3, 4. Where's the 5th mark, folks? Goodness, maybe simplifying this bracket, I guess, or multiplying by this flipped. It doesn't really matter. Fact of the matter is that we showed every step. If we made a mistake, checking answers here will reveal the mistake. Otherwise, not checking answers, you will not know that you made a mistake. And guess what? You will get your script back and you will realize you've made a mistake. But this time is all too little, too late, because you're not going to get marks for that mistake. So please, folks, don't throw away marks because of laziness. Because some of you like to finish quick in writing and for no reason you go and fail. When I was at school, I used to have my colleagues, some of my colleagues, of course not all, they would finish like early, man, and then you'd be like, wow, I'm actually struggling here. How are people finishing so early? Only to find that they have failed, and you thought you were struggling and you find that you passed. So please, folks, stop allowing other people around you to inject some negative influences onto you. Sometimes let them be how they are, but let it be a case study for you. Just observe them. Do not say anything. Don't copy them. Just observe first and see what they do, if it actually rewards them in any way. And if you see it doesn't, you may as well not consider doing what they do. But if you see it works to some extent, try to find out when does it work, when does it not work, so that when you adopt it, you don't adopt it blindly. Because if that's the case, you will always use it wrongly and fall like they all do. But if you adopt something that works occasionally, you will understand exactly when to use it and when not to use it. And so the same behavior may just benefit you. For example, when I was at varsity, we used to just go into the computer lab sometimes and not study and just play games there. And everyone would see us playing there. Even when there's an exam tomorrow, they'll find me playing a soccer match. There was this Euro 2004 game, It usually was just a 5-minute thing, but we just kept on switching players and teams and just playing and winning and losing sometimes. But, some people would be like, but those guys relax. Maybe relaxing helps. And then they try it and then they fail. But they don't realize something. When I'm there playing, it's because I am taking a break. I'm not playing when I'm supposed to do a lot of work. I've already done my homework a long time ago. During lectures and attending and what, I've been studying. But now I don't want my brain fried and tired the next day, because there I'm going to be tested for understanding, for critical thinking and problem-solving skills. So I cannot do those things if I'm carrying a tired brain from just overly studying things that I'm not even going to code and use effectively. Because, I mean, trust me, guys, studying the night before and intensively so is a waste of time. You may as well not go and write the exam because you're just going to go there and fail hopelessly so. But if you just study when you have time and allow your brain to code the knowledge and information, practice it enough, then relax your brain occasionally. I promise you, your brain is not going to fail you. Yes, anxiety is part of all of us. We panic and be like, maybe I'm not doing enough. What if I could have done something that helps me? Well, it just depends on luck, honestly speaking. But how often do you really depend on luck? Not so much, eh? In fact, you even get it when you least expect it, mostly. You don't get it when you're praying for it and hoping for it. Anyway, guys, whatever. Now let's get to the last question here. We are asked to calculate possible. Usually questions of this nature are naughty. Possible values. A possible value of a squared plus b squared. Okay. If it is given that a and b are rational numbers. Now, what are rational numbers? It's any number that can be expressed as a fraction of integers. Maybe let's not write a. We can say perhaps a is equal to c over d, right? Where c and d are integers, right? So a rational number is a number that can be expressed as a fraction of integers, meaning whole numbers, okay? And if it can be expressed as a decimal, it's a terminating decimal. Now, a recurring fraction, or what we call a recurring decimal, is literally a rational number because it can be expressed as a fraction of integers. But non-terminating ones are irrational because they cannot. For us to do so, we need to rationalize by rounding off or rounding up, whatever. You understand now? You do. All right, so it says now such that the square root of a plus the square root of b is equal to the square root of 9 plus, within that same thing, square root of 56. Now this is like, wow, what is this? And we can already see it's not a child's play. And certainly it's a higher grade question because no standard grade student can attempt this and win. But now I'm going to show you techniques that you can use so that every time you get a question of this nature, even if your brain is a standard grade brain, you will know how to scoop some marks, whether you finish or you don't. Now let's have a look. What do we do here? We can clearly see now, this is where we can solve. A plus b is an expression. A squared plus b squared is an expression. So usually here, the best way is to simplify. And we want the value. So the value is going to come from simplification. So we can't simplify something like this. Certainly, this is an equation. And so we can solve. We solve equations, right? And simplify expressions. So essentially, this is already indicating this is the guy to start with. And obviously, we need to solve for a and b. Now, a and b is already suggesting that we're going to have to use simultaneous equations. But can you see this simultaneous equation is very strange? It's within the same equation, as opposed to having two separate equations like we did initially and like we did in this question. There was an equation that we could solve. But now here, within the very same equation, we need to get ourselves simultaneous equations. So this is already indicating how to behave in this question. So it means a whole lot of thinking, a whole lot of constellation of rules and understanding, logic needs to come into effect. So let's see, what can we do here? We need to look into this guy first. Square root of a plus square root of b is equal to the square root of 9 plus the square root of 56. Okay, now We know, guys, with radicals we can square because we want a, so we have no choice but to square. So we can write here square root of a plus square root of b all squared is going to be equal to this square root right here. All right, so this is too long. I don't like it. Even here, oops. So always try to do the gymnastic on a separate step than the original, okay? Because sometimes we may want to go back and check if we can. Now let's see, what is this? Square root a squared is going to be a plus the square root of this times the square root of that. Set rules are going to say if we're multiplying two square roots, we're effectively multiplying these numbers under the same square root. So this is going to be this times that, which is going to be ab. So it's going to be square root of ab, and then we multiply that by 2. It's going to be 2 times the square root of ab. Oh, my b just wanted to cripple my writing. Oops, don't lie, it's not over yet. And then we square that last one, is going to be b is equal to, when we get the square root here, we get 9 plus square root. Now 56, we know that, we can check. What is 56? Is 23 times 2. I'm 28, sorry, 28 times 2. So this is 28 times 2. But 28 is 14 times 2. So we want a perfect square and some prime factor. So this is going to be 28, which is 14 times 2. So 2 times 2 is 4. So this is 4 times 14. Okay. Again, we can use a calculator here if we don't know, just to check and be sure. But always set up the mood first and get it right. 14 times 4 is 56. Okay, good. So now what do we do, guys? Because now we have a problem. Are we going to square again? I mean, take the square root. Are we going to win? It's going to be a horrible situation, you know, because this radical is not going to go away. It's just not going to go. It's going to just give us flavors of radicals that we don't need and don't want. So at the end of the day, we need to think critically. Now, as a medical, oh goodness, I'm dreaming about medical students. As a mathematics student, no matter what level you are functioning, if you got here, remember guys, you got a mark here. Remember, this is 5 marks. You will get marks here, even if it's 1 mark. Just simplifying this thing as well, gonna give us marks. Let's do that. So this is a plus, let's bring in b. You know, most in grade 9, grade 8, grade 10, we were told to group things because we can see we've got 2 terms on the right hand side. Now remember guys, always try to look at the expressions. You see, I've got 2 terms here, and if these things are equal, can I attempt to create 2 terms here? But those 2 terms, I need to do it strategically. So I can see there's a square root and there's a whole number. A whole number can come from 2 numbers adding. So I can easily group a and b because they are both rational numbers. And rational numbers can give us a whole number when added or whatever. Plus 2 root ab is equal to 9 plus square root of 4 is 2 square root of 14. Now it looks a bit nice because I've got 2 terms. This makes up 1 term. And we were told these are rational numbers. Now these things can add up to a whole number. It happens, right? For example, a half plus another half gives us 1, which is a whole number. So that's the logic right here. And we can see that we've got a 2 square root something. 2 square root something. So that must be related to what is under that square root. So this means a times b is 14. It means a plus b is 9. Logically, can you see we've split now into 2 equations that we can solve simultaneously. So this implies that a plus b is 9 and AB is equal to 14. Logically, that is the third step. Then we continue. We can decide and say that A is going to be 9 minus B, right? Right, and then we make this equation 1. And we can say AB is 14 and make this equation 2. Because we need to solve simultaneously. We then say put 1 into 2. Now we got A is going to be 9 minus B times B equals 14. This is going to be 9B minus B squared minus 14 equal to 0. Why did I do that? I shouldn't. Now guys, I'm going to skip some steps. This is going to be minus B squared, but when I'm transposing, it's going to give me B squared. This is 9B, which transpose is going to be minus 9B, and then 14 is exactly where it should be. So good. So we can factorize here. Most likely we might win. So this is B. Now 14 is going to be minus 7 minus 2, and that gives us 9. Therefore B is a 2 or B is a 7. Therefore A is going to be 9 minus 2, or A is going to be 9 minus 7. So this is 7, this is 2. So as we can see, guys, these values are just switched around. They are just switched around. So it's more or less, if B is 2, A is 7. If A is 7, B is 7, A is 2. So it's more or less the same thing. So we can say then we answer the question now. Then we can say A squared plus B squared is going to be, you can choose any. So A can be 7 plus 2 squared. I don't like to write like this, but I'm forced now. This is going to be 49 plus 4, which is going to be 53. Nice and easy. Okay, so can you see, guys, simultaneous equations first, and then we go back to the expression that was given. So here we simply had to substitute, no choice. Can you see, guys, it's an essay type question. It's horrible for those who don't really like mathematics. And of course, I like the part that says possible, because we could easily be wrong, but logically everything seems to tie nicely, so we cannot cry about it. But now here we cannot prove if we are right or wrong, because usually these manipulated expressions have no specific original. Perhaps we would just want to make sure that within this framework of our solution, within this part of our solutions, right, we can just check these solutions and say, well, if we go back to these, if we consider these expressions original, or these ones original, say for example, A is 7, B is 2, multiply those two, we get 14, so this balances nicely. Or we go back there and say 7 plus 2, that's 9, equal to 9, so it balances. But the problem is that if these equations are wrong, then we are wrong here, irrespective of whether the solutions balance. So this is one of those questions that you just make sure, whenever you can check a section for correctness, you stick with it. Whatever else goes on, you don't care, because there's no way of proving these solutions into the original, because now we've got square root, and 7 and 2 are irrational under the square root, so we cannot really proceed and say that thing is equal to this thing. You understand, guys? So that is the situation. Of course, perhaps there's a way of doing this. Perhaps there's a way of doing this. I don't know of any. But hey, in life, guys, you just see what you see and you just deal with it and wait and see what happens about it, okay? So yeah, I'm just thinking of how could I prove that these solutions work if I plug, say, a 7 there and a 2. Because now there's no denominators here. That's just the problem. Now, how do we rationalize this thing? How do we rationalize this thing? But there are lots of techniques, guys, There are lots of techniques that we can use to get this to look like that, But I'm trying. Guys, let's not waste time anyway. I'll think about it. If I did, I'll bring up this expression again and show you guys, maybe at the end of the video. So obviously, have 5 marks here. Certainly the answer is good. And perhaps choosing A and B, that is 3 marks already. And of course, you see, these equations are critical. Without these equations, we are dead. So this equation is important to come out. And that equation is important to come out. The substitution can be considered, but at this stage, I think the equations take precedence because we needed to derive both of them from a single equation and separate. This is like now, separating an expression into its parts. Okay, you can call it an equation fractionation. Or what is this? Partial fraction decomposition. So we're decomposing an equation literally. So I think the marks are seated there. The rest of the gymnastics here, we've been getting marks for doing it. I don't think it's that interesting. But this one may also be a consideration for a mark. Again, it depends on the examiner. Sometimes they may just say 1 mark for both equations here and award a mark. But again, it's too weak. It's too weak. So it depends on how heavy the mark weighs in a particular instance. Again, guys, we could be walking away with our nice 17 marks. As you can see, guys, a 3-step approach is the best because if you look at things, you inspect them. Now, the inspection part and examining and analyzing is usually what I would call the doctor's approach because that's what they do. But the rest, when you start to solve the problem, is the 3-step approach. But as you can see, the 3-step approach can actually influence even the doctor's approach in a way. If you understand certain things, sometimes you may not see it or even notice it. But when you look at the 3-step approach, this is my options. This is what I can do with it. What can I do first? Then an idea comes back. Okay. No. Yes, this can work, but let's hold it off and start somewhere. Then come down and perhaps we would win. And usually it works. Okay, guys? So I hope you enjoyed that part. Now let's do sequences and series, which is applications of algebra and functions. So please, sequences and series, think of them as application of algebra together with functions because those are interrelated. If you separate them, you will die when it comes to higher order questions in this section. But higher order questions are very simple here if algebra is on point and the knowledge of functions is checked. Okay? Anyway, 3.1. We're given a linear number pattern. So linear means it's an arithmetic progression. So what is an arithmetic progression? Is a list or a sequence of numbers such that there is a common difference between any 2 consecutive terms of that sequence. So this is -5, -9, -13, and this ... are suggesting that it continues in this manner. Okay? Understand notations in maths, guys. They have implications. And if you ignore these things, when you get a crazy expression somewhere in your future, just for an example, just look at the maths paper 2 for May, June 2025 that I produced for grade 12s. Look at one of the trigonometric questions. This notation is there, and many students don't know that that means it repeats like that. Now, whatever you noticed when you inspect, you're going to continue with it and then solve using the 3-step approach. Sometimes it's not so easy. As you could see there, I was dancing around and almost choking because guess what? I don't always have all the answers ready-made. At the same time, even what I know, I don't see it immediately. It has to come from thinking, because I know questions of that nature, even the thought process, the planning, how to approach it the first time will matter on how well you're going to do on that question. You just don't freestyle those kinds of questions. If you freestyle them like the common questions, you will fail them and they will make you miserable. All right, good. So this is arithmetic, so we're going to have a common difference. -9 minus -5 is -4. -13 minus -9 is -4. Okay, so this becomes a sequence as long as that continues, so to speak, and we know this is common or constant. Right, so this is good. Let's answer questions now. 3.1.1. Write down the next two terms of the pattern. So we've got T1, 2, and 3. So we're going to say T4 is going to be equal to, just say -13 minus 4 is going to be -17. T5 minus 17 minus 4 is going to be -21. Done. No need for formulas here. But you can go about it that way, still acceptable. Now determine the expression for the nth term of the pattern. So we know that Tn is A plus n minus 1 times D. This implies Tn is equal to A, this is -5, plus n minus 1, which is -4. Tn is going to be -5 minus 4n plus 4. Therefore, Tn is, now both terms are going to be negative, so we may as well write it in the standard linear format. So that's it. Okay, good. Now remember guys, once we get things like this, we need to check if it is representative of the original sequence, because we may have made a mistake in our gymnastics here. So if we put a 1 in there, this is -4 minus 1, which gives us -5. Let's check a non-contiguous term, like -13, which is the third term. So we're going to put here 3. This is -12 minus 1, that's -13. You can even go to T5 and say this is going to be -20 minus 1, which is -21. So this is definitely bulletproof. Easy marks, guys, can be lost easily if one is not careful. Of course, substitutions are more important here, and the final answer. Great. So we've got 3.1.3. Question says now, we need to calculate the value of n when Tn is -141. So we know that Tn -141 implies that -4n minus 1 is -141. So this means -4n is going to be transpose, is going to be -140. Therefore n is so I'm thinking 140 divided by 4 is it 18? That is born 140 divided by 4. When I 10 balance on column 18 and in tata maths ayisekho kulo muntu ku 35 kodwa kanti ndicinge kahle long division by 4. So we just forget the symbol now. Let me just see. I actually didn't do my math correctly. Remember, when I'm using my mental calculation, I'm actually doing this in my mind. I'm not smart. Don't even think about it. So 4 can go to 1? No. Then we bunch these two. How many times does 4 go to 14? 3 times. 3 by 4, that's 12. Of course, there's that horrible negative going on in there. 1 minus 1, 0. 4 minus 2 is a 2. We drop our 0. 4 to 20 is 5. 5 times 4 is 20. There's that horrible negative floating around, gobbling everything up. So I know that my quotient is my answer. Okay, I didn't do such a good job. Of course, guys, in NBTs, you will not have a calculator, so you might as well revise these techniques, long division for arithmetic, for algebraic expressions, so that this doesn't become your stumbling block when you don't need it to be. All right, so 3.2, we are told that in a linear number pattern, again, linear meaning arithmetic. What is an arithmetic pattern? It's when a sequence is such that any two consecutive terms have a common difference. All right, now the first term is x, we are told, and the common difference is 5 less than the first term. So this means d is equal to x minus 5. Right. Now this is essentially a higher grade question. Yep. It says calculate the value of the first term, okay, meaning x, if it is given that the sum, now we need to know word problems, the sum means plus, of the first 3 terms of the linear pattern is 63. Okay, we're given an equation in words. So now what do we know? We need to write the arithmetic progression. First is x. Now the common difference is going to be x minus 5. So we simply add x minus 5. It's going to be 2x minus 5. Third term we add x minus 5. This is going to give us 3x minus 10. And then this would continue like that. So we are told here that x plus 2x minus 5 plus 3x minus 10 is equal to 63. That is given. So this implies 2x plus x, 3x plus, this is 6x. So we can say 6x is equal to minus 5 minus 10, that's minus 15. Minus 15 plus 63, going to be 78, right? Yeah. 78, let's see, 63 plus 15, yeah, boom. So therefore x is equal to, that's 78 divided by 6, which is 13. Okay, yeah, it's 13. 1 or 3 lento lena. So okay guys, this one is the one. Okay, this one is the one. So unfortunately these questions can be a nightmare, but the best way to check it is probably to go back here, but it will almost always work. So everything needs to be structured well, otherwise there's going to be problems. So well, if you put 13 here, let's see, 13 plus 2 into 13. I'm doing wobbly. 13 plus 2 into 13 minus 5 plus 3 into 13 minus 10 gives us 63. But of course it will tie up. But if this equation is wrong, then everything is wrong anyway, even if it ties up. So critical step here for me is to write the sequence, and it should be correct for us to win here. Second is to then write the equation as was given, but remember it was given in words, so we needed to write it up, and we are getting a mark here. So this is 3 marks. So what does this mean? It means each term of the progression is a mark, because honestly we didn't know. But this one is a bonus because x was already given as x. Perhaps if somebody just said in a linear pattern, this is it, you get it, then you decide as a student. I guess the examiners failed there to make this question even a serious higher grade for 5 marks, because the first term should actually be, unless someone may want us to state that this is the pattern with D, we can say here D is x minus 5. Maybe the extra mark can be shifted from there to here, because of course D was critical to interpret correctly, but I don't think it has that much of a big deal if we can get the terms, I suppose. But hey guys, 5 marks in the bag, so we take our 11 marks with a big smile and move on. So you can see guys that there's a lot of rigor of mathematics that you gotta know. If you don't, you're going to be in the cold, and it's not nice there. You will ice up, or should you say you're going to freeze. And freezing, Mafeto, is the most painful thing. You can see that you want to move, but you can't move. You can see things going and you can't go. Right, and to melt is another issue. Okay, so be very careful. Don't find yourself in trouble. Let's get to question 4, still sequences and series. Now in grade 11, you're doing 2 series, or not series, but sequences. It's arithmetic, which is literally from grade 10, lately. And we did sequences and series probably, in fact not probably, but the right way in grade 12. Grade 11 and grade 10, we're just doing the basics of them, just exploring. First, the linear. You're given a sequence and then you complete it by adding terms. Sometimes by inspection, finding the general formula like a quadratic thing and stuff. That was all about it. But in grade 12, we then studied these properly. Now, everything is just spread out, and I feel like it's a bit of a nightmare because guys are not going to understand the significance of these things. There's a reason why certain topics must be taught at grade 12, not because they're difficult, but because they sum up everything a student knows, so that by the time the student moves on to the next level of study, which is, higher institutions of learning, that knowledge has been nicely consolidated. But now it is spread about like this. It's like floating in the air. Students like to forget what they've come from. They almost always look in the future hopelessly because they don't have any tools that they are bringing. They are hoping for new tools instead, because they are not people who learn to know and understand. They just are moving with the wind. And that's not right, but that's what they do. Now guys, we're trying to make sure that you're not moving with the wind like a paper. If it goes north, you're going north. If it goes south, you're going south, unless something traps you. Even that we don't like, because you should not be trapped. You're a human being. You should outmaneuver any situations you may find yourself in, using all the knowledge, the experience, the tools, the teachings, sometimes even your instinct, because your instinct improves when you know a lot, and comfortably so. Even your hunch becomes better than just a natural hunch. You will weigh things faster before you make big mistakes in your life. Anyway guys, it's not a life lesson. Let's look into this question. So we're given this number pattern. Of course, in a same question paper, if one has spoken and solved on a linear, definitely this should be quadratic. Although it may be linear, but if it is given linear, it will be a portion of the quadratic. Just know this. So there's always clues and ways of knowing what to anticipate. So I would say this is a quadratic progression for sure. Now this is going to be 24, 10, 0, and minus 6, okay? And of course, the thing does its own things. Let's see if it is quadratic indeed. 10 minus 24, minus 14. 0 minus 10, minus 10. Minus 6 minus 0, it's minus 6. Okay, this thing is going to continue. It's a sequence on its own. Now 10 minus minus 14 is going to be 4. Minus 6 minus minus 10 is going to be 4. So we can see that definitely the second difference is constant or is common. This should be a quadratic progression. Okay, good. So let's answer some questions. So this is 4.1. We are told to show that the above number pattern is quadratic. Copy and paste, papa. See, sometimes a bit of rough work is good enough. I don't know why I copied this thing. I should have just, let's just cut. Let's just delete it. We need to move this down because this is what we need to show. Then we move this up. Okay. All right. Okay. So after this, guys, we need to make a conclusion. Of course, here we don't write this now because we are checking it out. We can say now, therefore, the sequence is quadratic since there is a common second difference. Right, nice and easy. We need to show, guys, that we know what we're talking about, and definitely we don't just show this and stop. Okay, nice. This conclusion is key, and that show, in fact, as a whole, the whole thing is good for a mark 2. Or one can just easily get 2 marks for the answer because this is, means to an end. But a conclusion has to come out. Now the second question, we need the nth term of the quadratic pattern in the standard quadratic pattern or form. Alright, so we know that 2a is equal to 4. Therefore a is 2. Now remember, guys, this is generally expressed as 2a. This, of course, not necessarily this one in particular, but the very first difference in a quadratic pattern can be expressed as 3a plus b, okay? And the very first term of the quadratic sequence can be expressed by a plus b plus c, right? Right, so this is what we know. So we don't waste time here. Unless we didn't go to class, then we will have problems. Because these are just simple questions that don't need complications. Although, when you watch my video on quadratic sequences, which I produced in the channel for grade 12s, but you can go for it as grade 11s as well, you will see that I showed you every technique that you can use, because some questions are not going to follow the standard. So you must also be comfortable doing anything. So this means 3 into 2 plus b is minus 14. Therefore b is, this is 6 minus 14 minus 6 is going to be minus 20, which implies that 2 minus 20 plus c should be 24. Therefore c is, now this is minus 18. When you say 24 plus 18, that gives us 42, right? Therefore Tn is going to be 2n squared minus 20n plus 42. Answer. Now guys, again, we don't just get happy we got it. Let's check if this represents each term of the sequence. We put a 1 in there. This is going to be 2. Put a 1 there, that's 22. Minus 20 is minus 18. Minus 18 plus 42 is certainly 24, right? Right. Check another one. Say term 1, 2, 3, 4. Let's say term 4. A non-contiguous term, just to make sure there's no coincidences here. So this is 2 into 4 squared minus 20 into 4. Sometimes don't abuse your brain. You still need it to concentrate. So I'm getting minus 6. So this is definitely representative. So I should accept this as correct. So the marks is actually, the individual coefficients and constants, and then putting it together. All right. 4.3, we need to calculate the value of T52. So we know that T52 is going to be essentially 2 into 52 squared. Remember, this is a sub-question of question 4. So if we wrote the general term, we don't need to write it again. 20 into 52 plus 42. Therefore, T52. Remember, this is a subscript. Spare that. I cannot write it so small here. So 2 into 52. What did I do there? 2 into 52 squared minus 20 into 52 plus 42. This gives us 4,410. Now this one, guys, it's all about correct substitutions and getting the answer. Otherwise, if that is not right, everything is gone, okay? There's no checking it for sure. It's difficult to do so. So 4.4, we need to determine the smallest value of the quadratic number pattern. Now smallest means minimum. Now since this is quadratic, we look at the status of it. We saw that the coefficient of n squared, which is the highest power, is actually positive. Now it means it's a smiling parabola. So a smiling parabola has a minimum value at its turning point. So the minimum value is basically y at the turning point. So we know that the minimum value is going to be equal to 4ac minus b squared divided by 4a. Okay, so this is what helps us in a quadratic to find the y value at the turning point. So 4 into a into 42, is it 42? Yeah. Minus into minus 20 squared divided by 4 into 2. All right, so let's do it. I've got this one, 4 into 2 into 42 minus into minus 20. Remember, substitutions, guys, must be correct according to a formula we have shown. If nothing works, we are dead. So this is minus 8. We are done. No need to complicate matters when there's a simple way, okay? But if you don't know it, then go about it the hard way. This time, 3 marks, of course, substitutions and answer. But this formula is not normally given, so it becomes heavy enough to score a mark. Okay? Now, what other method could a student use here? If we think about it, we could easily write our quadratic in. We can do what we call factorization by completing the square. So we know that Tn is going to be 2. We take the 2 out, it's going to be n squared minus 10n plus 21. Okay, that's when we factor the 2 out. So it's going to be 2 into, then we take this, we have the coefficient of n, then we square this thing because it would have created a perfect square, because we simply add to this to create a perfect trinomial, which ends up like this, plus 21, and then to this we immediately subtract minus 5 squared. Just going to take you through the process, otherwise I should not be doing it. You should be doing it by yourself. So this is 21 minus 25. This is going to be minus 4, right? Then we redistribute the 2. This is 2 into n minus 5 squared minus 8. So we can say here, or one could pursue this technique of writing our Tn. We can just say Tn is equal to 2 into n minus 5. Remember, I don't know if in grade 11 this is called examinable, but in grade 12s, it is somewhat not examinable to do the completion of the square, but it is quite a useful thing. I don't know why they say that. But anyway, guys, for 3 marks here, what matters is to know what to do here. Secondly, what do we know? We know that this becomes the y value at the turning point. So we can say, therefore, minimum value is equal to minus 8. The other way to think about it is to say, well, we know that this is a perfect square. Now, a perfect square is either 0 or greater than 0. It is never negative once we solve. Now, we want the minimum, so it means the minimum here means this perfect square must be a minimum as well. And what is the minimum value? Is 0. 0 times 2 just literally kills this term, and we remain with minus 8. Okay, there are many ways of looking at this, but please be able to look at the factorized form, especially when using completing of the square in a quadratic, because it helps us to know which direction it can take. Otherwise, when it is expanded, we cannot say much about it. Although this works, but it actually hides certain things, but improves how to predict what happens to this function under different conditions. Nice and easy, guys. So again, there's marks for this. Remember, writing in the turning point format is mark worthy, so we could get 2 marks here for this, for each term of those 2 terms. We could get a mark because these come at a price, right? And then get the extra mark for the last one. That's if one decided to write in turning point format. I'm not too sure if a student needs to show the actual process of completing the square until that answer. That I don't know, but as you can see, 3 marks here is good enough to write this and this. This whole process is unnecessary, it seems, but I like it because when we say show all your workings, we mean everything you have done. Listen to me saying we say. Am I a teacher or an examiner or a marker? Not any one of the above. I'm actually the least person in the world you should be listening to, because I will plant ideas into your brain and you'll run into problems with your teachers, because their egos can be easily bruised. Yikes. Listen to me talking nonsense. Yeah, man. 4.5. Now the question says determine the values of n for which the terms of the quadratic number pattern will be positive. Okay, so what does it mean? It means Tn must be greater than 0, which implies 2n squared minus 20n plus 42 must be greater than 0. Oh Lord. So this is again quadratic inequalities. It makes this a higher grade question. Quadratic inequalities that we did in question 1, it's coming back here, and we need to show what we're doing here. So we know that we're saying Tn must be greater than 0. This implies that 2n squared minus 20n plus 42, not 52, must be greater than 0. Well, we can factorize. Okay. So we can factorize this thing, right? Right. Sometimes I like to just go for it. So this is 2n. Factors of 42, that can give me 20. 42, let's try 6. 42 divided by 6, 7. 6 and 7 will do it, because if we put 7 here and 6 there, we are good. This is going to be 14 plus 6 gives us 20. We are sorted. So what do we know? We can put it on the Cartesian plane. On the Cartesian plane. But this time we adopted or adapted to n as the variable. So this is the n axis, that is Tn axis, and that is 0. Now guys, I want you to know how to draw the graph on sequences and series so that you can tell what is right and what is wrong. Now we saw this is a smiling parabola, so it's going to be doing things like this. Since the y-intercept is positive, all the terms are going to be positive. We know it. So this is how the graph is going to look nicely. But now we know one thing for sure, that term 1 is the very first term here and nothing else. So this means this is 1, and so this graph doesn't exist above that part. That's why I'm dashing it. So the first term is this. Then we saw that this is going to be 6 divided by 2, which is 3, and this is going to be 7. Now the question is, when is this graph above the n-axis, or when is it positive? We'll see that, well, if we look here, that's positive. Remember, 0 is not included. And we can see that in this portion here, that is also positive. So what do we say now? We write that x must be less than 3 but greater than 1. But look at 1. It's positive still, so we can include 1, okay? Or x must be greater than 7. Now remember, once we write inequalities like this, we are suggesting that any real value above 7 should work. So we need to write the domain that n is an element of natural numbers. Please guys, even for real numbers, state it as much as it is implied. State it so that you get out of trouble when you get here. Because if you're not used to stating it, you're going to leave the answer here. If this part is missing, guys, this answer is invalid entirely. I swear to God, it does not make sense. Be very careful of just giving things without thinking. All right, okay, all right. So there's our graph, and we know what works. Can you see the graph only takes term 1 and nothing else? Be very careful of this. It always catches up with people. So usually 2 marks for this and 1 mark for that. That's the 3rd mark. 4th mark is stating the domain. Without stating the domain, these inequalities are invalid. Usually someone may want to entertain factorizations, perhaps want to entertain the graph, but usually we don't really focus too much on the graph, okay? But watch out, think of these, sequences as functions. You will never go wrong. You will never go wrong, okay? Nice. Was there any other way of thinking about this? I don't think so. Because I think we're going to waste time. At least at this moment, I think let's just leave it at this, Let's just leave it at this and not complicate it, because time is not something we want to toy with. Let's just get to functions. Okay, this is a nice, how many marks there? 15. Okay. Question 5. Now we're starting functions, another application of algebra, perhaps in more detail, because it also helps us back in algebra to think of things as functions. So question 5, we're given lines y equals minus x plus 4 and y equals x minus 2 are the axis of symmetry of the function at 1. Now this function of ours, we can see that it's really functioning. A is negative. So when A is negative, we know that our graph is going to be in the 2nd quadrant and 4th quadrants, literally. That's the shape. Now we know that we're missing P and Q, but anyway, how do we get P and Q at the points of intersections of these two? Because equations of the axis of symmetry are concurrent, or should we say they come together. Let's not use the word concurrent, because concurrence is only 3 lines doing so. But you can tell that at that point, it's when the asymptotes meet as well as the axis of symmetry meet there. So those are, in fact, that's a point of concurrency, essentially. But anyway, let's not complicate terminologies as well. Don't seem to talk about that anymore. Don't know why. Anyhow, so literally we can find this by solving those two equations simultaneously. And that's the first question. It says we need to show that P is minus 3 and Q is 1. Now there's two ways of killing this cat, literally. 5.1, we can kill it the standard way. We can just say, well, we can say we can say the center, because that is the center of this graph. The center is such that minus x plus 4 is equal to x minus 2, which implies that we move this, is going to be minus 2x is equal to minus 6, and therefore x is 3. And therefore y is going to be, which substitutes this 3 into n, is going to be minus into 3 plus 4, which is going to be minus 3 plus 4 is 1. We can say therefore the center is going to be 3 and 4. We can say therefore P, we always take the negative version of whatever we have there. It's going to be minus 3, and Q is going to be, I don't know where the 4 came from, goodness. It's going to be 1 from the center, which is the point of intersection of the asymptotes as well as the axis of symmetry. Right, that's the center of the parabola, of the hyperbola. So we are scoring 4 marks here. Solving simultaneously, knowing that we need to do so, is good. Solving for this, good. Solving for that, good. And then I would say perhaps putting this together, but that's more like giving the mark. I don't know, because these ones are already there. But I think what would warrant marks more is perhaps here, these two. Because knowing that we need to change the sign is mark worthy. Knowing that we need to maintain the sign is mark worthy, I believe. All right. Yeah. And in fact, we can even do it differently and say this mark, no. This mark, no. But we can say that and this, still okay. Or we can say, oops, substitutions into one equation, knowing we needed to solve simultaneously perhaps is good, and stating the ordered pair, and then knowing that we need to change the signs. Because remember, even if it's given, it's still mark worthy if there's some important steps like this. Now let's show each other how else could one have done this. We know that, well, y is equal to x plus p plus q, using that equation. And we know that y is equal to minus x plus p plus q, right? These are the equations of the axis of symmetry. This implies that y is going to be equal to, we write here x plus p, in fact the bracket is gone, plus q, and y is going to be equal to minus x minus p plus q. Now we look at what we were given. We can see that this is the positive gradient, which is this one. So it literally means this minus 2 must be this p plus q. Right, again, can you see the technique that we used in that equation when we wanted to extract two equations? Yebo. Yebo, yes. Yebo, yes. So we can safely say here, this implies that P plus Q is equal to minus 2. And we can say here, minus P plus Q. Again, we see that this is the one with the negative gradient. And where is the negative gradient? There. Oops. Thereabout. So it means now minus P plus Q must give us the 4, okay? This is by inspection, folks. Okay, good. So we can say here, therefore, P is going to be minus 2 minus Q, right? Make equation 1. And minus P plus Q is equal to 4. Make it equation 2. And we can say put 1 into 2. What do we get? Minus P is minus 2 minus Q is equal to 4, which implies that 2 plus Q is equal to 4. How? Kutheni kwabanjena ke manje? Angisayitholi phela. How? Sekwenzeke njani ke manje uma sekunje? Hayi akusazi okay. Therefore, Q is going to be what? Aye, Emanyana, why are you not coming out? Can go when? Hello, finally, poor man. This is good. When we isolate P, it's going to be minus 2 minus Q, and then here, minus into this plus that, it's going to be minus X minus P. So minus P plus Q must give us 4. Ain't it? It's like this. So minus P is minus 2. Oh, yeah. I have made a mistake here. I'm missing a Q here. So you see, it always tells when something is not adding up. It always tells. It always tells. So this means here I'm going to have 2Q here is equal to 2. Therefore Q, perhaps there's too many conclusions now. Therefore Q is 1. Therefore P is going to be minus 2 minus into 1, which is minus 3. Okay, this one doesn't make you change signs and stuff. So whichever you're comfortable with, folks, do it. Just do it. So for 4 marks, ngiyacabanga ukuthi lokho kubalekile nalokho kubalekile ukufaka omnye komnye. Yayibona kodwa ke ngonathi into ebalekile. These ones have been given, I suppose. Ukufaka omnye komnye is fine. Nokufaka omnye komnye is fine. Yeah, bese siyavuya kanjalo. Yayibona yonke lento. Sesiyavuya nje kanjalo. Nathi nje kanjalo. All right, guys. Easy 4 marks otherwise. Now we need to find the x-intercept. 5.2, we need to find the x-intercept of f. So first we write f in full this time. It's going to be minus 3 over x minus 3 plus 1. We can then now say for x-intercept, it is such that 0 is equal to minus 3 divided by x minus 3 plus 1. Right, so it means we substitute f of x as 0, which implies we transpose 1 becomes minus 1. Since we've got fractions, we might as well show it that this is a rational number. Then here we multiply by the common denominator, but here we just simply simplify our lives by just cross multiplying. So we get minus x plus 3 is going to be equal to minus 3. And we've got minus x is going to be equal to minus 6. Therefore, x is 6, right? Therefore, the x-intercept is 6 and 0. Remember the question said x-intercept. What do we understand by this? An x-intercept is a point on the graph. Otherwise, x is equal to 6 is just any horizontal line that passes through 6. So sometimes we try to think of a graph, although this is controversial and sometimes effectively ridiculous as well, because we can poke holes into it, but try to think of it as a point, because when we talk of a function or a graph, it's just a series of points that follow a certain pattern. Okay, at least we know what we're talking about. Points, they speak more value than just any horizontal line that we don't know what it's doing. Are we doing a horizontal line test or a vertical line test? You know, but at the same time, we cannot really read too much into this because it's not really that strong. First, we get that mark and that mark, provided we write the ordered pair. I believe this is key, but some people may differ with me on this one. So 6, oh, I'm in a hurry, 5.3. What do we have? We need to calculate the y-intercept. So y-intercept is such that we take f of 0, which is going to be minus 3 over 0 minus 3 plus 1. So this implies that f of 0 is, this is 1, 1 plus 1 is 2. Therefore, the y-intercept is going to be 0 and 2. Alright, so substituting 0 there, good. And getting that value, but I still believe the ordered pair should come up, because this is a point on the graph, not just a y value per se. Okay, nice and easy. As I said, it's a bit controversial, so don't read too much into that. We need to sketch the graph. Clearly label all the intercepts and the axes with the axis and asymptotes. Okay. Great, so we can do it. So we've done all these calculations. Sorry guys, I'm a bit tired. Actually, I'm on duty, folks. I'm risking by doing this video, you know, because if I get called up and I have not rested, my lord, it's gonna be horrible for me. All right, y there, that's the origin. Always label these axes nicely, folks. Don't be in a hurry. So we saw that our asymptote is at 3. So 3 we can say perhaps here. Remember, this doesn't have to be to scale at the moment, but I'm not happy with this one. Are you 90 degrees? Okay, looks like it, but it doesn't really make me happy. And then we can say this is 1. Now remember, asymptotes need to be dashed. That's the notation for asymptotes in our syllabus. You get it. You get it. So the vertical one is at 3. The horizontal one is at 1. Now all is left is to draw the graph. So we know that the graph is here. Right? So where does it cut? At 6. So I just like to do this. I don't like these coordinates written like that, but it doesn't really matter. Whatever you are taught to do, But now I'm going to copy this dude and paste this dude. Of course, I have the luxury to do this, then I can swing it around. Be like, So sesiyakuthatha sizokubeka khona la. Sesikubeka khona nje la. Kamnandi nje futhi. Bese kuyafana nje konke lokho. Uyayifumana ke ngoku. Okay. So ikhatha kubani? Ku-2. There is our graph. Now all is left is for us to label it as F. So where are the marks? Is the shape of the graph, any one of the intercepts, be it y or x, and any one of the asymptotes. Okay, that's how we score those 3 marks. Nice and easy. Now we come to this question. It says, write down the domain of G if G is the reflection of F along the line. I don't think we reflect along, but we reflect about. Is there any significance to this? I don't know. Because for me, if you're saying along, it means you're flipping this graph along this line. Really? But if you're flipping over, maybe it's even better to say over, because if there's a graph here, if you're flipping over this means this distance must be equal to that distance on the other side. So that's a flip over. It's like, oops, it's a somersault, right? Along, about. Is there a difference? English, guys? I don't know. But I like common language, or perhaps used language rather than manufactured language. At times we need to say things that make sense, guys. We need to just refrain from causing controversies. In the exams, we must not have controversial statements. We must not have controversial questions, controversial calculations. Whatever that is controversial must be out of the exams. But we can trick students using what we know for sure. They have no excuse not knowing. Then if they die, we are not at fault. But if you bring in things that are not even certainly taught, or that we can prove for certain that should be taught, yeah, it looks and feels good that, yeah, they should know, but the reality is you're crippling our nation here. Cannot examine kids in a way that they are not taught. Those guidelines that you put out there, yeah, all nice and dandy, but are you also ensuring that the teachers who teach the subjects in every school in this country is proficient in maths? I don't think so. So how dare you examine kids when you don't know if they are taught by the proficient teachers in the subject? This is why we need to really think about it. Doing exams, or maybe making an exam, is not as simple as people may think. You know, just sit there and take a textbook and design questions. You have to think about a lot of issues. So this is why there's quality assurance, there's coordinators and what, peer reviewers and stuff. It's for reasons of this nature that different opinions of qualified and excellent people in this subject can sit and consider different conditions, but some of them come from these conditions. They themselves experience these challenges. Now they know exactly what brings them to the fore, and they also know how to intervene. They used to be school inspectors to ensure that the curriculum is effectively, delivered or executed at school level, and even performance of each class was evaluated by inspectors. Where the hell did those people go? Because the last time they came, I was doing sub B, which is 1995. Never saw them again. Where the hell did they disappear to? Because how will we know that the schools are doing what they're supposed to do? The teachers are doing what they're supposed to do. Guys, sometimes we make professions look so easy and so simple. And remember, folks, there's also an issue of a drop in performance of an individual. You see, we submit what we call the PMDS documents every quarter, because these things, they carefully evaluate if someone is still performing at the level they're supposed to. Spare that people do this as some form of formalities, because you will see that the assessments are ridiculous. Everyone keeps on scoring threes. I mean, if I was scoring threes in 2015, how likely that I'm still scoring a 3 in 2025? And no one sits and carefully examines these documents and see that the people who are just giving scores here are just dishing scores that they pick in their head. There are two things that should happen. It's either I have moved above or fall below, but there's no way I can stay in the same place, and yet the years are going by, my experience is piling up. Are you serious? Now, I don't know about teachers if they submit such documents or anything, but again, do they really get evaluated at all? Because yes, we submit, but nobody actually evaluates these things. They just put there for formalities because it's policy. Can you imagine how ridiculous we are? Anyway, guys, whatever. So 5.5, I may be tired even. Now, we're told to write down the domain if this is reflected about. I would prefer what is commonly used to avoid confusions, because when you're saying along, what are you telling us? Have we ever reflected a graph along a line? I don't think so. You get it? Because remember, this is a vertical line like this. You see? And we had a graph there, we had a graph there. So if we are reflecting along this line, x is equal to 0 is basically the y-axis. It's also the line x is equal to 0, right? So if we flip about, it means what was here is going to sit there, and what was here is going to sit there. So this graph is going to sit somewhere like this, you know? So we're converting the graph that was there and there into a graph that is there and there. But now if we're saying we're flipping this graph along, we are trying to suggest that we are flipping this graph like from, I don't know now, what is the point of reference? We're flipping it from here to here, from here to here, from here. Alright guys, don't say stupid things, man. Dembella, please do. I know creativity is important, but don't be careless in creation. You create for us, you know, malformations. And malformed things are very difficult to keep. They're taxing. And yet, they're not of any value. You lose eventually. And now you realize that everything has been a waste. Okay, please. Okay, so theta kakhulu akusenandaba ke. So let's see g of x. If it is reflected along or about the x-axis, because x is equal to 0, sorry, it's the y-axis. So this means it's going to be f of minus x, right? Because whenever we do a horizontal reflection, this becomes what we call a horizontal reflection. So this is essentially what this means. So this implies that g of x is going to be minus 3 over, where we see x, we will replace with minus x, and then minus 3 as it was, plus 1. Now we will then be patient with the process. We have minus 3 divided by, we normally don't like x negative under that denominator, so we factor out a negative. It's going to be x plus 3 plus 1. Therefore, we can make a conclusion that g negative divided by negative is positive. It's going to be x plus 3 plus 1. Now, can you see exactly this graph now is going to be in the first quadrant, third quadrant. This is definitely suggesting that. Alright, okay, alright. Of course, a horizontal reflection means the y values remain. As we can see, the asymptote, the horizontal asymptote literally remained as is. It didn't change. So there's a lot of things. When you study, guys, You don't just solve these problems and then you go, I'm happy I've got it right. Yeah, I'm gonna kill it. Watch what you are doing. First, solve. After finishing, you will notice that after I've done this horizontal reflection, guess what? This did not change. But what changed is the numerator, the sign changed. The sign on the denominator changed, especially between the two terms, literally. Now you will see that whenever someone says this reflection in a strategic way, you know exactly what's going to change. And you don't need to go through this pain after that. Somebody says, write the equation of G that is reflected. That is a reflection of this. You don't go through this mess. You just know, okay, I'm just going to change the sign there and the sign in between. And that's all. You understand, guys? That's what you call studying. Because after studying, you go back and notice what is going on. And you can start to make notes about this. That with the horizontal reflection of any hyperbola, the sign of the numerator will change, as well as the sign between the two terms in the denominator. And that's all. If it was negative, it becomes positive. If it was positive, it becomes negative. You see, you've got quick and shorthand techniques now of doing this without worrying about the process of doing it algebraically, because that's time wasting. In the exam, you then use your shorthand tools, but wisely. How would you use this comfortably in the exam? Because you have been studying them during your practice sessions, during your tutorials. You've been asking questions. You've been testing these in different equations, because now when you actually do study, you'll take a different equation and do the same reflection and see what it looks like, so that you can generate some common, should we say, is it axioms? Yeah, because those become true statements, even if you did not really show a proof of. But you can actually see that now, man, I've got it, it's in the bag, I'm doing it. Now, guys, what is the thing about the domain? Now, the domain is only restricted at the vertical asymptote. And of course, it's going to be the opposite sign of what we have there. So we can just say, therefore, domain is equal to the x value such that x is an element of all real numbers, but x must not be equal to the vertical asymptote. I like to write it like this, but you can write the interval notation. Why? Because x is an element of real numbers. If not, please do not write the interval notation. If you are brave enough to do it, rather state the domain afterwards. If not, that answer is invalid mathematically, because it doesn't make sense if someone reads it and yet it doesn't transmit the same thing it seems to stand for. Okay, all right, folks. Now, what is the key here was to write our reflected. Again, I hate a question like this that just says write the domain. You see, a right kind of an answer, it says answer only. And that's usually 1 mark and 2 marks maximum. For more than 2 marks, you cannot just write down the answer. This is ridiculous. So this is one of those crazy questions I hate. And it just shows that whoever was supposed to look at this paper as someone who's going to be sort of like functioning as a peer reviewer, or should we say whatever person who's supposed to make sure this process is coordinated, is not doing it. Because when they read these questions, what sense comes to their mind? Do they just agree? It just means, did you submit the paper? Yes, I did. Okay, yeah, make sure you send it. How ban? Then they get paid for not doing due diligence on the papers. This is why these papers are so many. There are so many mistakes. Every year there's mistakes on these papers. If there's no mistakes, there's just misconceptions. And we wonder why our students don't make it. I plead with you, teachers, and whoever is at the position of doing something about these issues. The reason I'm highlighting is not to make myself look smart or sound smart. No. I never see myself better than anybody. I'm just better than my old self, that's all. The only person I'm in a competition with is myself. Yes, it doesn't mean I don't feel the pressure when others around me are perhaps achieving things that I'm unable to achieve, or perhaps struggling to achieve, or not even knowing how I'm going to achieve them. Yeah, those things do place me under pressure, because I also have personal goals that I know if I was to reach, I would never be pressured by anything I see around me. But sometimes it happens, I'm human. But folks, I don't compete with people. That thing escaped my mind a long time ago, because I realized that you will always be defeated. Because people, you don't know what they are hiding. So you will just blindly go and compete with them and then be humiliated. And when that happens, everybody laughs at you. You will sink into depression if you do that. To protect yourself and to have a peace of mind, just don't give people the impression that you can do what they can do. Just showcase it when it's done. Then they'll be amazed. Oh, this one can do this? Yeah, one. Maybe let's look at this one. And when they do, they will find you solid. Because you must never be what you cannot represent any day. You must always become what you can stand for and represent. If someone puts you to the test, they will meet you in your A game. But if you fake things and try tricks and whatever, yes, it will give us the impression that you are there. But then when we give you the test that really separates the weak and the strong, babies and adults, you will fail. And when you fail, when we put you on the test, remember, you are almost cursing your life at that point in time. Because once we discover that you're not what you seem to represent, we will never look at you the same. Even when you have transformed and changed, we'll probably not consider you if there's a next person to you. So please, guys, remember these things. They have an impact on your future. And this is where it gets hard. It's easy at school. It's easy at varsity, relatively. But when you get to the real life out there, you start to wonder why I'm suffering, why I'm not getting there. Because there's more to achieve. In fact, it's even harder, more unpredictable. You live in hope and faith, I'm telling you. Yeah, anyway. So guys, for 3 marks, you cannot tell people to write, ne? It's wrong. It's wrong. So, but it means you're getting these marks like this, it seems. So this means you can write g of x by skipping all these steps, which for me doesn't make sense. It means just write this and then this thing as well. But now whether this is wrong or right, nobody cares. But here's the problem I have with this, is that what happens to a student who probably couldn't get here, but at least understood that they are supposed to substitute a minus x there? Do you want to tell me that that student doesn't deserve a mark? Because now you decided the answer only, and the answer must have the answers that we don't know where they come from. At least the first one. This one is easy, we know it's coming from there. But where does this come from? Because we're not just testing the answer, guys. We want to know, can the student generate these things? Because it's all about generation. It's not about the outcomes. We already know the outcomes. Can the student reach those outcomes? So that we can trust them with our future tomorrow. But hey, ntloheleng ke tlo bolela thata ke na le mollo. Hey. Wasikwa waphola uwamba fuethu. Awukho buhlungu xa ndithetha. Fact ndithetha nowasenilele xa ndiphupha. For which values of x will x times f of x be less than or equal to 0? Now this is another higher grade question here, which students will be banning. In fact, this one is a higher grade question, technically. Don't know why I chose to make it hard, but whatever. I'm tired of stopping it now. Now, guys, what is going on in here? Now, again, guys, if you don't understand what to do here, look at this as two functions being multiplied. Let's say we've got the function y is equal to x and a function y is equal to f of x, right? Think about it. This is an inverse line, so to speak, and so it passes through the origin. The gradient is 1. But of course, I'm going to draw this graph here, but don't draw it here. This is the graph that you need to present for answering the question, not for this purpose. So please don't do it. But I'm doing it now to show you guys this is the line y is equal to x. And this x right here is this x over here. Okay? So basically y values of this graph multiplied by y values of f of x, right? So now this means y values of f multiplied by y values of that function. When is that product less than or equal to 0? Now we can see that when this graph is at 0, meaning the y value is 0, or the x value is 0, if you think about it that way, multiplied by the y value here, which is positive, what do we get? We get 0. Is 0 included? Yes. So this means that that point is taken. But what happens when x is greater than 0? When x is greater than 0, the y values of this function are positive. The y values of that are positive. So positive times positive is greater than 0. So this interval is forbidden. This is the asymptote. It's never acceptable. Let's see past the asymptote what happens. The y values of this function are negative. The y values of that function are positive. So negative times positive is negative. That's less than 0. So this interval is good until we get to 6. This is 0. Y value is 0 there. 0 times any positive value or any number for that matter is 0. Is 0 included? Yes. So 6 is included. 0 is included. Beyond 6, when x is 6 for the hyperbola, the y values are positive and the y values of that function are also positive. So positive times positive is positive. So this part is forbidden. Then what happens on this side? When the x values are negative, this y value is negative, but the y values there are positive. Negative times positive is negative. So that interval is good. So how do we write it now? Okay, let's write it here and then take it down. So we're going to have basically x as less than or equal to 0, or x must be less than or equal to 6, but greater than 3. We cannot include 3 because it's an asymptote. Right. So we just take this answer down, copy, and paste. Okay, let's write this one a bit better. Okay, good. So we get a mark and like that. So 3 marks. So it's not too bad once we know what to do. Of course, here if it says just for which values, it's like determined by inspection, by any means necessary. But please don't mess up this graph when you submit the question here. Rather draw a separate graph instead and then mess it up if you want. But at this point, I'm just trying to show you how to use what you have to get yourself out of the problems. So this is 3 marks. So this is going to be a total of 17 marks. Nice and easy, guys. So this is not something to panic about. We just perform our job and get away. How else could one do this? Remember, when no one dictates how we should do it, we can explore our options. Algebraically, you can say this is x times f of x, which is f of x is basically minus 3 divided by x minus 3 plus 1, right? Right, so this is x. Of course, we're saying this must be less than or equal to 0. This is x into common denominator here. This is over 1, right? It's going to be x minus 3. Then what do? This divided by that is 1. 1 times that is just that. So this is minus 3 plus This divided by that is this. This times the numerator is just x minus 3. Okay. Less than or equal to 0. So we're going to have x into, we simplify the numerator. So it's going to be x minus 6 divided by x minus 3 less than or equal to 0. Remember here we cannot cross multiply because we don't know the sign of x minus 3. It is variable. It can be positive, can be negative. And when we cross multiply here, it will have to affect the inequality. The equal sign, yes, not, but the inequality may have to change. Now when something can be both positive and negative, it's not conducive to do so. Now once we've got our binomial factors, we leave them as they are. We just put them on the table. So we're going to put x minus 6. Oops, my battery power is down. Then we've got x minus 3. And what is the ultimate here is the product. So this is multiplication. But we need to remember how this is going to go. So we're going to have 3 values of x here. So basically we need to appreciate the fact that these two are a division. We need to deal with that first, then we do the multiplication of the result. Okay, nice. So what are we doing here? We solve this by equating to 0 and solve. So this is going to be 0. Then we equate this to 0, it's going to give us 3. Equate that to 0, it's going to give us 6. Then we start asking ourselves, when is this 0 here? When x is 0. Beyond that, it's going to be positive. Below that, it's going to be negative. When is this 0? When x is 6. Beyond which is going to be positive, below which is going to be negative. These are linear expressions. When is this 0? Here. Above which is going to be positive, below which is going to be negative, right? Now we say negative divided by negative, that's positive. Positive times negative, it's negative. Negative divided by negative, that's positive. Positive times 0 is going to be 0. Negative divided by negative, positive. Positive times positive, positive. Negative divided by 0 is undefined. Undefined times positive remains undefined. Negative divided by positive, that's negative. Negative times positive is negative. 0 divided by any number is 0 times any number is 0. This positive divided by positive is positive times positive, that's positive. Now where are the solutions here? Is it included? Yes, 0 is included. But how do we want it? Negative. So we're going that way. And then we jump this because this is positive. We don't like it. Here it's undefined. We put an open circle. 0 here is defined. We shade it. But in between we've got our solutions. So how do we write them? You can say therefore x must be less than or equal to 0, or x must be less than or equal to 6, greater than 3. Can you see it solved the pain? Nice and easy. You can even state here x is an element of real numbers. So please learn the table method as well. But of course, if you watch my videos, you will see it often. Most of the videos I've done in the past, I have tried to show you this because it works all the time. Because nobody says how you solve this. So if you used it, remember it says table, formula, graph, whatever you did to use to solve, please show us. But usually questions like this, an answer only is good enough. As you can see that we get a mark here, 2 marks there, 3 marks. The domain this time is not really that strong because the graph itself, its domain is an element of real numbers. So we are safe when the element of real number, when everything is an element of real numbers. The moment it changes, we are not safe if we don't state the domain. be very careful. So that's exactly those 17 marks, guys. I just wanted to push you a little bit to the limits. Now let's get to the parabola, which is question 6, but I need to charge my tablet for now. Let's just do it quickly and then see. Okay, it's still 90%, it's not too bad. So I want to sleep at 3, so I don't know if I will have finished by then, but I think if we can finish these functions quick, I may have to skip that financial math section and the probability, because it's probably not something you're gonna write about in term 2. So, but I will decide, because I'm also tired. I don't think I'll finish those questions. Otherwise, I'll be boring you. All right, guys. So, let me just drink some water. All right. So, okay. Now, wow, what am I doing? Question 6. Hi guys, I'm feeling a bit beat. I am tired. And I have an early morning. I have a case, maybe 2 cases in the morning. So let's probably just do the functions, which is what you're going to do, and stop. And then I'll carry on with the rest of the paper later on, maybe as a separate video. In any case, you're still not going to watch this video anyway in numbers, so whatever. I must not break my neck for nothing. Okay, sketched below is the graph of f equals x squared minus 4x minus 5. It's a parabola, smiling face. We see it nicely, where x is an element of minus infinity to 6. So the limit is at 6 here. As we can see, when x is 6, this is now a restricted graph. It's not element of real numbers entirely. Yes, element of real numbers, but x stops at 6. Now, a and b are the x-intercepts of, A and b are the x-intercepts. Yes, we see that. So it means we've got some x value and 0. And then here some x value and 0. Then c is the y-intercept. Of course, it's the constant term, which is easy. So this is minus 5. And yeah, that's it. So there's not much here to say, so we just understand that this is just a restricted graph. So let's just shoot into the questions. In fact, we can even factorize this expression to find those x-intercepts. So this is x, so it's going to be minus 5 plus 1. So this gives us a minus 1, this gives us a 5. Okay, we're done. So let's start answering. Determine the value of f of 6. That's not a problem. It's going to be, where we see x, we put a 6 squared minus 4 into 6 minus 5. Therefore, f of 6 is what? This is 36. This is 24. So 24 minus, 36 minus 24, that's 12. 12 minus 5, that's 7. Yeah? Of course, do engage your brain when you can, but don't abuse it. In the exam, you need it to concentrate, so please take it easy. So it's just 1 mark. Okay, not a problem. 6.2. Determine the coordinates of A and B. Those are the x-intercepts. So we can say A and B are such that, let's just say f of x is equal to 0. These are the x-intercepts, which implies that x squared minus 4x minus 5 is equal to 0. We factorize. Most likely we will win, and of course we already saw that we won. So we can say therefore x is minus 1, or x is 5. Therefore a minus 1 and 0, and b is 5 and 0. Question said coordinates. So we need to show the ordered pair. How many marks? 3. Of course, substituting 0, factorizations, and of course showing those ordered pairs. I'm giving more than is given. Okay, perhaps that is good, but we can say then factorization here, or equating to 0, either one of the two, the mark is there, but we can consider it depending on how the distribution of those marks are to go. 6.3. Hence calculate the length of AB. Easy. AB is a horizontal line. So AB is going to be x at B minus x at A. We don't need to apologize for that. It's going to be 5 minus into minus 1. Therefore AB is going to be 6 units. Remember guys, when a length is asked, we need to state that this is a distance by by indicating units. If it was centimeters, then we put it as such. Okay. Again, this is an easy one mark. No need for any troubles there. 6.4, we need to write down. See, this is another issue I have here, because you cannot tell me to write down for 3 marks. What is it? What are you doing? Write down the equation of G in the form. Can you see? This is already going to involve a calculation, but I'm getting only 3 marks, and yet I'm supposed to just write down. You see that? These are really not cool, man. But let's do better, people. If it is given that g of x is obtained by shifting f of x, we're shifting f of x 2 units to the right and then 5 units up, okay? Not a problem. So we're going to write g of x is going to be f of x minus 5. Is it minus 5? Minus 2. Then plus 5, right? Right. This implies that g of x is going to be, now this is x. Where we see x, we put x minus 2 squared. Minus 4 into x minus 2 minus 5 plus 5, okay? This implies that g of x is, we expand here, x squared minus 4x plus 2, which is minus 4x, plus 8, that is 0. Those are like terms. Then we write the final equation. Can you see it involved a calculation? It's going to be x squared minus 4x is minus 8x. 2 plus 8 is plus 10. This is a lie. This is a 4. My goodness, I'm losing my mind. You see, now I'm not concentrating. I'm really tired. Yo. Yeah, I've had a long day. I'm still going to have a long morning. X squared. So this is minus 4x. Minus 4x is minus 8x. 4 plus, this is plus 12. Okay. That is what it is. Is it plus 12? Aye, man. Yeah, it looks like it. Looks like it, guys. Wrong or right? What was the question? We needed to write g of x in this extended form. At this point, if you spot a mistake, you let me know. I am not in the mood. Fine. What did we do here, guys? Substituting the x minus 2 first was good. The second one is substituting the plus 5. Okay, maybe we can say those two are good enough, and the final answer. Can you see it's not just writing, it's a process of calculations. So that's an inappropriate question, basically, in terms of the instruction is not good. But the question is good itself, but the instruction is misleading, so we should not have such. Anyway, whatever. Just suppose H is a tangent. Okay, what do we know? Tangent is a straight line that touches a curve at only one point. Now to the curve of f at a certain point, okay, we don't know this point, with a gradient of -2. So obviously this suggests that the tangent y is equal to -2x plus c, which the c is what we will need to find out, okay? If we ever have to. Then we need to calculate the y-intercept of h. Okay, that's a good higher grade question. See, I'm happy with this one because it definitely will involve a calculation, okay? I think it's going to be a rough ride. Let's just go to the next page. 6.5, we know that at point of tangency, which we would call the port. Remember, we want to use this as an abbreviation if we ever need to find that point. There are two things here. The two graphs are equal, meaning they have the same y value for the same x value. Two, they share the same gradient at that point, okay? That is very important. But again, the gradient part comes when we're doing differential calculus in grade 12, so don't put too much. But all you need to know in grade 11 is that at the point of tangency, the two graphs have equal roots. So we know that f of x is going to be equal to the tangent line, which is, perhaps we can say y, whatever we want to decide to put it, and such that these two have equal roots. But at this point, we just want to simplify first. So this is x squared minus 4x minus 5 is equal to minus 2x plus c, right? But now we see this is a quadratic expression, x squared, we transpose everything, it's going to be minus 2x, then minus 5 minus c is equal to 0. Nice quadratic. But what did we say? They have the same y value for the same x value. Now the same x value means equal roots. We can say then for equal roots, can you see nature of roots are very important. It is such that the discriminant is equal to 0. This implies b squared minus 4ac is equal to 0, which implies minus 2 squared minus 4 into 1 into minus 5 minus c is equal to 0. This implies that 4 plus 20 plus 4c is equal to 0. This implies that 4c is equal to, this is 24, so it's minus 24. So what do we get? Therefore, c is minus 6. Comes out nicely. Nature of roots. You wouldn't think about it because you need to be prompted. But this is a question on nature of roots. Please master it. This question always constitutes a higher grade question in functions. It's nice and easy in question 1, usually. But here, it can hurt if somebody is not clear. Great stuff. So, how do we score marks here? Well, equating the two graphs, 1 mark. Writing the equation of the tangent, 2nd mark. Then, knowing that the roots are going to be equal, this is a mark. And of course, the substitutions into the discriminant and the final answer should make up the 5 marks. Nice and easy. No questions on this one. All right, 6.6. Now we're told for which values of k will f of x minus k equal to 0 have just one real root. So what does that mean? One real root means equal roots, right? At some point, because the root repeats. Because we've got a quadratic, this is going to be a composite function, quadratic function like this one right here. What we just did here. Now this is again a question of nature of roots, which is essentially a higher grade question, but this one is a bit technical. And yet it has less marks. So what do we do here, folks? Now we need to think about this question in 2 formats. 1, f of x minus k. Remember, k is a constant. So this would represent a vertical shift of f, right? So this means we want to decide how can we shift the graph of f so that we only have one root. Obviously, let's just try to play with this graph now. Let's just play with it. Let's make it very red. So there's our graph of f. I'm going to try to draw it so that it's equal to what I have here, because it's going to be a bit squiggly or something. Because it's a free hand and I'm trying to concentrate. I'm going to have a tremor, an intention tremor. That's what makes this line squiggly. Now, if we shift the graph like this, will we have one root? At some point, yes. But let's just do this. Actually, let's just do this. I just want to make this one a bit longer so that we can see that this side is continuing. The arrow means it continues, right? And that side stops there, okay? So then we crop it. So remember, when we move, when we move this graph down, can you see as this point that was restricted moves below the x-axis like this? Do you see that? You can copy this one and then paste it and say, okay, that's the situation when we're doing the vertical shift. The second portion of it, we can shift it down so that that y value when x is 6 is below the x-axis, we get one root. Or we move it up until the turning point is seated there on the x-axis. That's when we've got equal roots, when the x-intercept is the turning point. Okay, this is when we are using the vertical shift. Watch what happens when this is the case. We will notice that this graph, when we shift it such that it's below, that y value when x is 6 is below the x-axis, it's over there. But do you see there's only one root, meaning one intersection with the x-axis. Or when we shift this graph up vertically, we only have one root at the turning point. So that's the scenario when we consider this composite function and k would function as a as a vertical shift of this graph. Obviously, we can now determine by how much must we shift this graph. Obviously, if we take our turning point now, we need to find out what is the value at the turning point. Okay, just trying to frustrate me, this thing. So we will know what is the y value at this turning point. What was it here? But we can determine it. It's not a problem. We've got a full equation. Then it means that y value is going to tell us that we need to move this graph at this distance upward. Because if we move this graph that distance upward up until there, we will have one real root. But the second instance is when we shift this graph down such that this point is below there. But we know now that this distance was 7 units, right? Because we saw that that y value was 7. So if we shift this graph down by more than 7 units, now when you shift a graph down by more than 7 units, we're going to say less than minus 7. Because when we take it down, the 7 must be negative. But now anything bigger in the negative sense, okay, let's say smaller, then logically we would know that we should say minus 7. Okay, guys, so these questions are not so easy. If really you're not comfortable with functions, you will usually not answer these questions and just leave them out. But I'm trying to push you guys to not, because these are easy questions, but they're technical. But you should love the technicality. So let's think about what we just did now. So what do we need? We need the y value at the turning point. Okay? So we can say here, certainly, we just want the y value at the turning point. We can say y at the turning point is going to be 4ac minus b squared over 4a. Can do this as a two-step kind of a thing. So it's going to be 4 into 1 into minus 5 minus 4 squared, all divided by 4 into 1. That was the function of f, right? What is it? This is minus 20 minus 16, which is minus 36, divided by 4. It gives us minus 9. Okay, that's realistic. It's not too bad. Nice. So we know now that we need to move this graph. If this is a vertical shift, we need to move this graph upward by 9 units. But now for this to be 9, it means if this is a minus k, this very k value must also be negative, so that when we multiply into this, it becomes positive, and that would constitute a vertical shift by 9 units. So we can say here, therefore, k must be equal to minus 9. Exactly that minus 9. Because there are two ways of thinking about it. You can say, I want to move this 9 units upward. You can easily say, well, I can say minus k in the equation must be equal to 9. This means we are solving for k by multiplying by negative. That's how you get it. You can look at it that way, but you can also logically look at the fact that if I already have a negative, for me to have a vertical shift up, this sign must change to positive. How can I adjust for this? 9 units up, but in this case I need to say minus 9, so that if k is minus 9, this is going to be minus into minus 9, which is going to be plus 9. Then that constitutes this scenario right here. Okay, that's the first one. But now how do we cater for the second scenario? This one is going to be a bit technical because it is brought about by this restriction. So how do we cater for that? Now this is going to demand a different strategy. Of course, we know that we need to shift this down by more than 7 units. But if we're shifting it down, it means 7 must be negative. But now a number that's going to be slightly bigger in terms of its true sense, negating the sign, we're going to say minus 7, right? Because minus 8 would then do the job. But if we just shifted 7 units down, we're going to hit the x-axis. Then we still have an x-intercept. So there will be 2, but we need 1, so this must fall below. Nice. So we can say also or. Now remember, this one would mean this is a negative k, right? You can say minus k must be less than, right? Not equal to, sorry, what am I saying? Not equal to, but less than. So this must be less than minus 7, because we are saying this minus k as a whole must be less than minus 7 entirely, so that this, if this minus k, remember this time it's minus k, must be a negative number, so that this number is also bigger than 7 itself, but then it should be negative. Then it will dip us below the x-axis for that point. Then we solve for k here. We can say therefore k must be minus 9. Or in fact, let's just showcase this nicely, guys, and say, well, let's just show this nicely so that it looks the same. So we can say minus k must be equal to 9, meaning the whole negative there, so that we don't look like we're cheating. So we're saying minus k here must be equal to 9, because we're saying we want to shift this 9 units up. Then we solve for k. That's the case. Or k here, the sign changes when we multiply, must be equal to 7. Remember, when k is 7, remember when we put greater than 7, that could be 8. When we put 8 here, it's going to be automatically minus 8. That would dip us below the x-axis. So this question is very technical, guys. Even to explain it is a bit cumbersome. It sounds ridiculous. So it's a very challenging question. Of course, we get a mark for each and for determining that value at the turning point. But I think the key here was its substitution, because then we needed to know something. I don't know, guys, but this is also marked worthy. Is that the one, or is it the substitutions? But I mean, if we are marking it here, we effectively used it here, so we can ignore it. But perhaps how we brought it into light. Okay. So as you can see, again, this involved a calculation. Without 1, we would not have 1. Okay. So how else could we think about this question? The other way we can think about this question is to say, look, f of x minus k equal to 0 is the same as f of x is equal to k when we transpose k. So it means we are saying two functions are equal to each other, but still this is a constant. So this means we've got f of x and y is equal to k. Now these two must be equal. So this is a horizontal line, right? Because this is a constant. So this means it's a horizontal line. So it is defined by the y-cut, right? The y-cut, or where that horizontal line cuts the y-axis. But now we choose strategic points. For this to be a single contact with the parabola, it could be there. So this could be y is equal to k. So when that is the case, can you see we only have one point of contact with the parabola? Again, it still speaks to the minus 9 that we got. So it means here, k must be equal to minus 9, right? Simple. So it just says it nicely. This one is even easier to look at. Or we can just say, okay, our graph must be copied, and then we just move it a bit. Now if we move it here, we're going to have 2 points, 2 points, 2 points, 2 points, 2 points. But above this, when this graph is continued up, like so, since the arrow is telling us, can you see here we're going to have, again, 1 point of intersection over there. But this is more than 7. So we can easily say, again, this could still be y is equal to k. And for that instance, k must be greater than 7. So this one is much simpler when we simplify this into two functions that are equal. But when this becomes a vertical shift, it becomes a bit technical on how you choose to write the expression. Okay, I hope we are clear, guys. So that's just the essence of it all. I don't know what's happening here. Anyway, guys, that's essentially how one can solve this question. Those two ways are usually very common. So those are common questions. So please score those marks. But you will definitely work for those marks. So these are the questions you would rather you answer while your brain is still fresh, knowing that the other questions are easy to handle, or you want to answer this very last so that you can score marks elsewhere if you haven't gone there yet. Nice and easy, guys. So I hope you will understand this and you will appreciate the majesty of mathematics. Let's do the last question, guys. I'm gonna cut it here. It's already 3 hours and I am tired. I need to sleep. Tomorrow I have 2 cases booked for operations, so I'm gonna have to wake up early and get ready to go. One of them is easy, but it can take a bit of time because it's a neonate, an 11 days old baby. And then the other one is an adult. This is a 43-year-old, but that case can be a bit challenging as well. So we'll see. Because that guy has two things. He has a brain tumor that was attempted for surgery at first, but he bled and almost died. So the surgery had to be interrupted to just save his life, just get a tissue biopsy, which was a horrible situation, honestly. But now the wound is leaking CSF, cerebrospinal fluid, so it's not healing, it's dehisced, it's not coming together. So now we need to go back and try and seal where the hole is. But now there's two things. Since there was a bit of cauterization during surgery to try and get that thing out, larger portions of that tumor now are going to be necrotic. So it means it can come out a bit safely than it would have in the first instance. And there's already a nice opening, so there's no need now to first work on the skull, which was bleeding as well. Now it's going to be easy. So now there's two things. Are we going back to take out the rest of that tumor and then close nicely? Because if we still leave the tumor behind, we're just bluffing. But what happens when it bleeds again? Are we prepared? Things like that. Is then ICU bed and what. So it's going to be quite a nightmarish situation in the morning. So I might as well get some rest, folks. As for the other kid, has what we call a meningomyelocele. Now these things you will see when you get to medical school. I'm not going to say a lot about, but what I can say, the cause, or should we say an associated abnormality that we pick up from women who give birth to these babies, is that they lack, or should we say they have low levels of folic acid in their blood before they fall pregnant, during pregnancy. And so folic acid is very, very, very critical in the development of the nervous system and its functioning as well. So at some point, then they develop what we call the neural tube defects, meaning what was supposed to be the axial bones that cover the spinal cord, then they don't develop. So the spinal cord remains exposed on the skin, and that hurts the nerves because of the amniotic fluid the baby is swimming in. Remember, the baby still urinates there and bobos that thing that is, greenish. We call it meconium. So those things are toxic because they hurt the baby. So those nerves get injured, and so they lose functioning of the lower limbs. They can't use them. So the problem now is that once there's that, it means they are at risk of getting infections into the CNS, like meningitis, which can horrify the patient. And also that thing sagging like that, it causes the brainstem as well as the cerebellum to descend in the foramen magnum. So the cerebellum sort of like herniates there. That can cause compression of the brainstem, the medulla oblongata especially. And remember now, the swallowing and the talking, coordination of breathing and swallowing is coordinated there. So if there's a compression of that part, you may start to have cardiovascular issues, because even the vagal triangle, where the vagus nerve to the heart comes from, so it can get interrupted. So there's also an area called area postrema. If it gets stimulated, they can vomit endlessly. Blood pressure is becoming difficult because too much parasympathetic overdrive will drop the blood pressures to low. Then if you raise them up, because there's loss of control now, then they go to the roof. So it's a nightmare. It's just swinging. And once that happens, you're going to lose your patient. And of course, if they cannot swallow well or coordinate swallowing and breathing, then they will aspirate every time they eat. Then they will have lung infections. that can lead to sepsis, and then they can die, So it's a catastrophic issue if it is uncorrected. Now, the problem with this kid, that MMC, or meningomyelocele, has ruptured. Now, when it ruptures, it means CSF is lost there. And now that means at an even higher risk of dying from cerebellar tonsillar herniation. So you see, interesting things, folks. I never knew I'd be doing scary stuff like this, operating on 11-day-old babies. Like, you don't even think those people are going to survive surgery, and hey, they do. Or removing a brain tumor, like touching someone's brain and slicing portions of it off, and they still live to see the next day and many years thereafter. It's interesting, guys. But again, this is all brought about by education. So if you get educated, you're gonna get to see things you never thought are possible, and even marvel at how well you will perform yourself, and even see more than has already been seen, or even bring forth things that have not been thought of the first time. So quite an interesting thing, man, to be alive and to have a vision. But when you're alive and just going through the motions, trying to live a soft life, but without a purpose whatsoever, it's just a ridiculous way of life, and that is very stressful, destructive, and many die too soon because of such things. But when you're obsessed with what works and what matters, and you give yourself for it, there's no way you're going to live a short life. Trust me, you're going to live long. Provided whatever you acquire it the right way. You work for it. You earn it. You don't get handouts. You don't get picked because of favoritism, and yet you don't really qualify for those things. Just be your person, man. Just be proud of who you are and what you stand for. Even if people shut you out, don't give you opportunities because they are threatened, or perhaps they feel like you're going to be too much of a person for them to deal with. Just hang in there and keep grinding. Don't forget to always develop yourself further than you already have developed. Don't stay in the same position. Don't stay stagnant. Sooner or later, something is going to give in. And what is nice is that luck is when preparedness is met with an opportunity. And guess what? When you are ready, yes, you may struggle for a few years after that to get things, because people are going to try to shut you out. But eventually, when something gives, you will be ready to take it. And when you do, you will surpass a lot of those who went ahead of you. But remember, that's not about surpassing anybody, though. What is good is that you will be able to do as much as you needed to, because sometimes a bit of maturity on your part is needed. Because you can't just pass medical school yesterday and then you become an intern for 2 years, still dependent on other doctors for functioning, become a community service doctor, and then you're still depending on someone's decisions for your functioning. Then immediately thereafter, you go and train for neurosurgery. Of course, you can. Then you'll just go there and then go through the motions, learn the very bare minimum, finish. Then we think we are good. We think you are good, and then we salute you. But you actually don't know much. You can't do much. Useless at best. And then later on, after some 5, 10, 20 years down the line, that's only starting to catch the drift, because that's when you actually fully mature. Because the ego as well is gonna have to be chopped over some few years by humbling experiences. And then at that very end, that's when you start to become something, but then it's too late. You're probably dying at that time or trying to retire, Think about certain things, guys. They have some negative impact, although they look conducive, because a quick success is what we always chase after. But sometimes what you have waited for, but waiting while preparing for it, I'm telling you, man, when it comes, you even marvel at how fortunate you are to have suffered to get there, because you will move faster and quicker to the actual destination that you need to get to. Then you'll spend the rest of your years just multiplying yourself, sometimes even through others, because you don't need to be a gatekeeper when you make it, okay? In fact, you need to be the gate opener. You should kick the walls that limit people, or you give them ladders to climb over to get to your side. When they get there, you drill them. You produce the best out of them. And to do so, you must not be kind in the manner that the world sees kindness, smiling, tolerating nonsense, being fair to stupid people. When someone shows up with a stupid attitude, kick them out. You're not being a gatekeeper, but you're just dealing with the problem. Cancer must not be allowed to set in. Once you see it, you remove it. If you don't, it spreads throughout the body. You can't do anything about it after that. Whatever treatment you give is going to fail, so it's a waste of time. So once cancer has spread, it's sometimes better not to do anything about it. But then, I'm talking about cancer now carelessly, but when it is in a human body, it devastates systems, so you need to support them. To say not doing anything about it is careless, I guess, on my part. But I'm just trying to talk about the cancer that is bad people. Because then they create confusions and distort the systems that work, create a very hopeless situation where everything goes and yet it doesn't mean anything for the rest of the communities that really deserve and need the best of us, So you kick people out when they don't show up for work. They don't do stuff that they're supposed to do. They don't listen to counsel. They don't evolve and develop. Things were stagnant and dependent on liabilities, man. You get rid of them. Isn't it? Yeah. Then when people you see, they deserve a chance, even if they don't look too prominent, you can see their zeal, their eager, their rigor at everything that you give them. Then you give them a chance. Because you can't say, I need a distinction candidate to become a neurosurgeon. That person comes with an inflated self-worth. It's going to wreak havoc because they will think they are gods. They will create chaos everywhere they go. But someone who is humble, but is reliable and dependable, deserves a shot more than the distinction candidate who's careless, just assuming at best. Because that person is going to make things happen. It's going to make the difference. But again, certain things have limits to themselves as well. There are some strange things like, the odd ones out. It's not always the case that when you're a distinction candidate, you're not going to be good enough, no. But many are not good enough, I promise you. Many are not good enough. People who graduated cum laude in this country, of course, I may not say the same about other countries, but in this country, yeah, they have achieved things. We know it. We know it. But I don't see the impact. That's just my problem. Maybe I'm too, I'm too nosy. Maybe I'm obsessed, I guess. Maybe I have OCD. And perhaps I think I see things that are better, but maybe I'm just seeing illusions and delusions. And perhaps I'm just hallucinating. I never know, man. Sometimes, when you're a person and you fail to self-introspect, you'll always over-assume yourself upon others and what they do. And yet, guess what? I'm not even an element in the set that they belong in, okay? I'm an outcast there. Anyway, guys, whatever it is, outcast as I am, I'm still gonna speak my mind, right? Right, of course, I'll try to be as fair as I can be. But when it comes to brutal honesty, I will not apologize for it. Okay, graphs of f of x equals minus into b to the exponent x. So what is important is to know that the coefficient of our power, now, the power is the rest of what we see. b to the exponent x is a power. And remember, b can never be negative in a function. So this minus, even if it's written before a number, we know that this is a coefficient. It's a minus 1 times the entire ordinal, okay? Plus 8. So what does this 8 constitute? A vertical shift. Of course, 8 units upward, right? Now, when this is negative, we know that we expect our graph below the horizontal asymptote. Okay, that's what this means. Whether now it's increasing or decreasing will depend on the size of b. If b is less than 0, not less than 0, but if b is less than 1, is less than 0. What am I saying, guys? I'm lying. Less than 1, greater than 0. When this is the case, it means the graph is an increasing function. Now we just come down here and have a look. We can see that the exponential function is this one, right? And we see that it appears below the horizontal asymptote. And by the way, this one should be at 8, because that very vertical shift becomes the horizontal asymptote. And we see this graph is increasing. So this suggests that our b is less than 1 but greater than 0, provided our a here is less than 0 as well. And we can see that the parameters are already giving us an indication of what we're going to come across here. Okay, great. Now move on to the next function. G of x is 3 over 2x plus 7. So this means there we have 7. Y-intercept, so this means this is 0 and 7. So we already have the coordinates of b from that straight line. And then a is minus 2 and 4, and b are the points of intersection of f and g. B is the y-intercept of both graphs, and we already saw that. Right. So now that we understand what we're dealing with, we just go straight to the questions. So 7.1. We need to write down the coordinates of b. Can you see? Because it's easy to see them. So this is 0 and 7. So we get our 1 mark. We smile on. 7.2. Show that b is a half. Can you see? Exactly. Structure, graph already presented exactly that our b is less than 1, greater than 0, meaning it's a fraction. It's a proper fraction. So what this means is that this is a proper fraction. And by the way, someone may put this as a statement and say b is a proper fraction. You should know the fact that that means b is less than 1, greater than 0 for an exponential function, of course. So pay attention to terminologies. They will haunt you guys. And you will remember me. When you are failing to produce the results, that will place you at the table of kings. Anyway, 7.2, we need to deal with this issue. So we know that f of x is minus into b to the exponent x plus 8, because we saw that this is going to be the one, but again it's given to us, right? And then we take a point on that, so we can say through point A with minus 2 and 4. We can even use the y-intercept here. 0, so 4 is equal to minus into b, x is minus 2 plus 8. Okay, this implies we transpose the 8, we get minus 4 is equal to minus into b. In fact, let's change this to positive exponents. It's going to be minus 1 over b squared. No, I don't need to. Do I? Hey! Ay man, sonibhedela wena man. Sikahlombhedela wena, sikambhedela. It's a jwal. Now we take this so that it changes to become positive. So I can say b to the minus 2 is equal to 8 minus 4 is 4. Okay. Now sometimes you just choose how you're going to fight this battle. You can change b, if you like, into a fraction, and then you're going to take a square root, a lot of stories. But what I like is just to deal with this exponentially. So this implies that b to the minus 2, we then change this by multiplying by its inverse. Or should we say by minus a half, right? Right. Whatever we do to the other side, we must also do onto the other side. So this is 4 to the minus a half. Again, guys, the way of solving exponential expressions is really a choice of the student. So those two take care of each other. Minus times minus is a 1. The key here is to kill the exponent, literally, to just a plus 1. So we can say here this implies that b is equal to, now this we change to a positive exponent, so this is going to be 1 over, then 4 squared, which is going to be 2 squared to the half. Right, I'm moving quicker now because I don't like to waste time. So what do we say? We can say therefore indeed b is a half. But another student could have gone simplify this into a positive exponent. For example, from here, can write 1 over b squared is equal to 4 over 1. Cross multiply and isolate b squared. This implies that b squared is 1 over 4. And we can write here that b squared is going to be 1 over 2 all squared using exponential stuff. Therefore, b is going to be a half. Because if the exponents are the same, therefore the bases must be the same for those two to be equal. That's the other way around. The other way around. Okay, maybe this one is much better than the other one. The other one looks scary and shaky, but it's valid, eh? Learn the tricks, because you never know when you're going to need them. So sometimes be a little bit flexible. Anyway, let's do it. So what is the story here? Substituting the point. Great. Just 2 marks, okay. Perhaps here we can say, the gymnastics here are probably more important. Yeah, substitutions, gymnastics, the rest goes nicely to where it should go. Again here, substitutions over there, the gymnastics, and the rest is history. Okay, easy 2 marks. So we need to do 7.3. We need to write down the average gradient between of f. See that? Average gradient of f between a and b. Now what do we know, guys? The average gradient between 2 points is literally the gradient of a secant or secant passing through those 2 points. And can you see the secant here between a and b is nothing but g. So that's the average gradient. So here we just write it down as the question says. So we know that MAB average is going to be 7 over 2. Right? It's 3 over 2. Goodness, where did I get 7 now? So the gradient of our function g, because g is a secant through those points a and b on the curve of f. Therefore, the average gradient is equal to the gradient of a secant. It's as if these guys saw a video that I made about this issue when I was discussing calculus, differential calculus to be specific. So yeah, it's a good one. So 7.4. So that was 2 marks actually. Yeah, it takes knowing things, but another student may first can use AB is going to be y at B minus y at A divided by x at B minus x at A. This is still perfectly fine, okay? Because we've got 2 points, you can calculate it, but when you know it, you just go for it, because the question said write down. It just shows that there's an easier way, but again, you do it like this, but remember, we don't need to see this one. Don't show us how you did it. The question says write down. We just want the answer only. And of course, this matches the question because it's just 2 marks. 7.4, we're also supposed to write down the equation of the asymptote of f. That's easy. Also, we can say y is equal to 8. So, easy 1 mark. 7.5, we're told to calculate the vertical distance between f and g when x is minus 1. Now we can see this is minus 2 already, so minus 1 is probably minus 2, maybe halfway there, probably there. So we can say, okay, maybe this is where minus 1 is. So which graph is above the other here? So which graph is above the other? It's f above g for the same x value. So we can just say vertical distance is going to be y, or maybe let's just say f of minus 1 minus g of minus 1. Okay, don't invert it when you can. So f, we saw that this is minus into a half to the exponent minus 1 plus 8 minus g. It's going to be 3 over 2 into minus 1. Maybe let's do that. Plus 7. Here we just punch the whole thing into the calculator. Minus into a half to the exponent minus 1 plus 8 minus into 3 over 2 into minus 1. Just make sure the substitutions are good. Sometimes it gets tiring and boring, so I'm getting a half. That's a very small distance anyway, so 0.5 I can accept. Although it's not drawn to scale, but the proportion there is already convincing, so it should be so. Right, guys, so we're getting how many marks there? 3, of course, substituting there, and the final answer. Guess so. So this is a calculation on its own, that's a calculation on its own. And then we put it down. So we're told to describe the transformation of f to h of this function. Right, now let's compare these two. So we know that f of x was minus into a half to the x plus 8. And here we've got h of x is equal to a half to the x minus 5. So what we notice here is that the negative is gone. It's positive here. It has changed. So now if anything affects a coefficient like that to be positive, it means we probably did a vertical reflection. Now vertical reflection, it means we multiply minus 1 by f of x, or we multiply f of x by minus 1. Okay, vertical reflection means we multiply the entire function of f. Sorry, we say minus 1 into f of x. Okay, so we need to think about that. And then after that, we see a minus 5 now. And yet we had an 8 here. So what happened? We must have shifted it some units, but now we cannot tell this as yet. So our job is to first perform the reflection of f. when we do that, we're going to say, well, the reflection is such that it's going to come out. Let's just say h of x is going to come out. When we multiply by -1, it becomes a +1. Oops. But this one becomes -8. Now we want to see, okay, now the first part has been achieved. This is positive, and that's what we wanted. Remember, guys, this is RW, rough work, because you cannot be too sure. Then we look now and say, okay, the next piece is to deal with this -8. How do we make it a -5? We can add 3. So this means we must have shifted this graph. After a vertical reflection, we then translated it or shifted it up by 3 units to get to -5. So that's exactly what we do here. So we're going to write the description of what we did now. 7.6. We can say h is the function of g, or the graph of g. We can say is g, not g there, it's f, sorry. H is f reflected about the x-axis, which is what we can also call a vertical reflection, and then translated 3 units up. Okay, one can say shifted 3 units up. So first, describing a reflection about a particular axis that's constituting 1 mark, right? And of course a translation 3 units up, or we can say a shift, will also translate to the 2nd mark. So this question is one of those taxing questions, because this is a silly higher grade question that makes you think it's just a walk in a park, and yet there's a lot of thought that sometimes can be very wrong, and you may not even reach the answer trying to do so. So be very comfortable with just checking things out first before you start your answering, because it can be a situation you would not want to see. Now we say, for which values of x is f of x greater than and equal to g of x? So literally we are describing this portion right here between a and b, right? Because f is above the graph of g for the same x values. So here 7.7, we can see x must be less than or equal to 0, greater than or equal to -2. Done. Alright, so x is an element of real numbers. We don't need to write that down. So guys, this would be the next 13 marks here. Otherwise, this one was a bit easy, except for perhaps 7.6, because I think that's the one that is crazy. Otherwise, guys, I will continue with this question paper on a separate video. I am very tired. I need to go to sleep. As I just said to you guys, I have an early morning, some hectic stuff to do, and it's a Friday, so people don't like to do hectic things on that day. So for me to survive the onslaught by these 2 patients, because you never know what can happen, especially the second one. At least the child, it's easy, but not always. But yeah, the second one might be because I'm also not decided if we're going to pursue that tumor. If we do, we might as well remove it completely, otherwise we're not helping the guy. If we don't touch it but we still operate, we're just torturing the man, taking him through the knife, and yet we're not addressing any of his problems. So sometimes it's difficult to be in this position. You just don't know what is right, what is wrong, what is fair, what is not. You just sit there and you're like staring into the distance. You're thinking, you want to bail, you want to try, but if you try and fail, you'll be ridiculed by the situation, even if people didn't do it. But sometimes they may do it and say, what the hell were you thinking, you know? Yeah, sometimes everything has its ugly side. You gotta love them both. I'll see you guys next time. I hope you enjoyed the review, and you will love it if you are a fanatic like myself of the subject and you're happy to explore options and look around and, finesse your work in a way. But these ones are term 3 topics, so I would rather we discuss them on a separate video just to give you a glimpse. In fact, question 8, 9 and 10 are term 3 work, which is not too difficult honestly, but time is not nice. And the dude is tired, guys. Let me go. Bye bye.